Connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Cap Gemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Cap Gemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Cap Gemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Cap Gemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Cap Gemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Cap Gemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
została wysłana request dzisiaj dopiero.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Z informacją, że z racji tego, że nie jest to nie a teraz się okazuje, że
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Hey, hi Lara, can you hear me?
So I see that you are talking, but I don't
Oh,
hear you.
just give me a second. Let's try. Can you hear me right now? Can you hear me right now? Can you hear me right now?
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Can you hear me? 1, 2, 3, 4, 5. Can you hear me right now? One, two, three, four, five. 1, 2, 3, 4, 5.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto.
Okay.
A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps.
Okay.
Say hello to a better way to build and deliver digital experiences. Contentful.
So we're just gonna keep that one open and we'll just mute the mic just in case. I just prefer to have it on last, but yeah. So how's it going? Nah, there's no possibility at this point. No, it's nothing because the computer doesn't have a microphone. Option for it, plus it's just playing the movie right now, so no way. Can you hear it right now? Or maybe you just capture it through the Discord.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
I'm jumping to it right now, just in a second.
Not all the time, but from time to time.
Maybe that's how one of the commercials is recorded. Is that possible? I'm saying this production, we don't have anything connected to my actors. Technically impossible. And I didn't do any voiceovers for any of these. Maybe there's something one of the videos somewhere. Or previously, maybe you just captured Discord because they had Discord all the time on my side. Maybe I accidentally used the edit or able to do it. I don't know. Okay, so where are you right now?
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Okay, so I'm gonna be back to you in 2 minutes. Just 2 minutes and a half. We're gonna stop the recorded video. So I want to be sure that I don't miss it. Okay. Be back in 3 minutes.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
Easier. Better.
Really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production, with lightning-fast security scans returning results for review and triage.
And we're off. Having the rear pump. Wait. Hey.
Hello, everyone. Welcome to the second day of JS Nation.
Hello, folks. Welcome to us.
We're so glad that you could join us again today, and we hope you recovered from our in-person first day as well. Quick word from us. My name is Floor. I'm a staff developer advocate at Ivan.io, which is a database as a service company. And joining me is one of my favorite ex-colleagues.
And I'm Maxim Salnikov. I lead developer relations in Microsoft Norway and super happy to be MC for JS Nation.
Absolutely. And you're joining us from all over the world. That's what we take from our registration. So if you feel like it, please post in the chat where you're joining us from today. And be nice to see where you're joining us from.
Huge thanks to our program committee for building this amazing program for all of us.
Absolutely. And of course, this conference wouldn't be possible without the support of the wonderful sponsors. Our platinum sponsors joining us are Capgemini, AG Grid, and AppRise.
And we also have gold sponsors: Focus Reactive, StackHawk, OLX Group, Decentralogy, Docker, Modus Create, Sneak, Contentful, and Bitwavo.
And a huge thanks to our silver sponsors as well. Thank you so much.
And you know, folks, we want to have Twitter full of photos of JS Nation today. And we want to see how you are watching us. Just tweet it with the hashtag JS Nation, and we'll be looking out for your tweets. Don't forget to use hashtag.
I'll use that hashtag then. Do you like to attend conferences? Then maybe you should consider getting yourself a JSNation multipass. With a multipass, you get access to all great events that are on this slide as well. And the pass will be valid for the entire 2022 and 2023 season. You can find all details on portal.jsnation.org.
You can find agenda and much more useful information on their website, JSNation.com. Just go there, you'll find everything.
Yeah, and a little housekeeping. Let's take a look at our watch page and how you navigate around. So you can see two tabs with two tracks, a video player, and a timeline underneath. You can just select the activity that you'd like to do, and the system will put you in the right place immediately, be it a speaker Q&A or a discussion room.
And if you want to hang out with fellow attendees, speakers, and join discussion and speaker Q&As, go to special.chat. You can join those with your camera or mic or just mic, whatever you prefer. You'll see a list of rooms on the right hand when you join. And once you are in the room, you can move your avatar around, and the closer you are to the speaker, the louder they will be. And very important announcement, all speaker Q&As will be held exactly on that platform. Go to special.chat.
Absolutely. In our schedule, we also have a couple of discussion rooms. The ones that are up to date are landscape of various JavaScript engines. Then there's JavaScript frameworks, and there's Web3 and blockchain discussion room as well.
And we have one more platform for the communication. Be sure to join the Discord server. You have link in your email with the ticket. Join this not to miss any announcements, as well as to hang out with remote speakers as attendees. And of course, ask your questions on channel's community track and residence track.
Yep. And we want everyone to feel safe and have a really good experience during our event. So please familiarize yourself with our code of conduct at gitnation.org/COC. We do not tolerate any form of harassment in any of our channels, so that includes Twitter, Spatial Chat, and Discord. If at any time you feel like there's been a violation of the code of conduct, please reach out to coc@gitnation.org and we'll take care of it right away.
And also, don't forget to check job offers from our amazing sponsors at JSNation.com/JS-jobs. There are all sorts of front-end dev jobs, especially React jobs at companies like Stackhawk, Decentology, Sneak, Capgemini, and more. Check them out. Check the digital perks too. You can win Nintendo Switch, drone, Sony noise canceling phones, and more.
And your feedback really helps the team in improving the event experience. So please find the feedback form at jsnation.com/feedback. Take your time with it and leave your feedback and thoughts there. It would really help us make this an even better event next time. So, are you ready to get started? Because I know we are.
So I'm thrilled to have been part of it. It's been a fantastic event.
Lots of great people.
Our wonderful sponsors have recorded a couple of messages for you, so let's have a look at those.
Crypto. Bitcoin. This coin, that coin. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
3T Software Labs makes high-performance tools for MongoDB, tools that power data teams worldwide. Our flagship product, Studio 3T, is the most highly rated client for MongoDB on the planet. Studio 3T, rated #1 by pretty much everyone.
And a quick word from our platinum sponsor. Capgemini is a global leader in partnering with companies to transform and manage their business by harnessing the power of technology. Capgemini is trusted by its clients to address the entire breadth of their business needs, from strategy and design to operations, fueled by the fast evolving and innovative world of cloud, data, AI, connectivity, software, digital engineering, and platforms. On to our speaker. Yehuda is, over the years, has worked on a number of open source projects, including Ruby on Rails, jQuery, and Rust. He has also created some of his own, including handlebars, Ember.js, and Cargo. At the moment, he's working on a new library that extracts the best part of Ember's auto-tracking reactivity system into a package that you can use in any UI framework that you'd wish. And that's what his talk is about as well. So please go to the community track and leave some applause, cheer him on, and feel free to ask your questions in the chat as well. And we're sure that he will join us soon to answer those as well. Judy Hott, the stage is yours.
Hi everybody, today I'm here to talk to you about Starbeam. Starbeam is a library for building reactive user interfaces based on the guiding principle that if you write your reactive code just like any other code, you can build radically simpler, more reliable user interfaces with the JavaScript skills you already have. Now, people have said a lot of similar things like that before, so I don't blame you for being skeptical and jaded. Before I get started, I want to be really clear about something. Starbeam is not the next hot new JavaScript framework. The demo I'm doing today uses Starbeam inside a React app, and we have similar examples in Svelte, Vue, and Ember. The people who work with me on Starbeam are pretty tired of the way that new front-end ideas are always packaged up with a whole new framework you need to migrate to. We think we can do better, and I hope that by the time I'm done here, I'll have piqued your interest. Let's start by taking a look at what the app that we're going to be building looks like. Here's the finished app. So we have a form, we can create some new users. I can write Leia Silber Portland. I can append it. As you can see, once I have appended it, there's some information on the bottom about what happened. I can filter. I can write Portland here. And when I do that, you see that this changes to say 2 filtered out of 5. I can delete items while I'm filtered. Everything works as you would expect. I can delete all the items. I can add people back in, like that. And that's about it. That's basically what this app does. Well, the very first thing I want to do is change to using the non-finished version of the demo. So let's start there. Okay, great. And as you can see, there's some features here already, but there's no filters, there's nothing that made it very interesting. And more importantly, nothing works here. Before we get started, let's take a look at the data that backs our component. Now, it's a little bit of an involved JavaScript thing here, but the reason it's involved is less that Starbeam cares that you do anything interesting here, and more that I want to show that even if you use pretty advanced, fancy JavaScript features, everything still continues to work. So let's take a look at the first piece of this, which is the table. So a table has an ID which starts at 0, and that's so we can allocate IDs as we create new rows. We have a list of rows, which is a map from a string to a row. Now, what's a row? Well, here we have an example of a person. So a person has a name, which is a string, a location, which is a string, and all a row is that thing plus an ID added to it. So we're going to map from the ID to a row of a person in this case, and that means it's going to be the person plus an ID. Okay, we're going to take a bunch of columns so that we have a way of reflectively creating headers. We're going to have a getter for rows. So what does the getter for rows do? It gets the values out of our map and splats it onto an array. This gives us an array back. How do we append a row? Well, we make a new ID as a string, and then we make a new object that contains the ID and the columns that we specified. And then we set the string ID onto the map and give it the row as the value and return the row. Pretty vanilla stuff. How do we delete an ID? Well, we delete it from the row. How do we clear rows? We clear the map. And then there's one additional feature here, which we're going to use to implement filtering, which is the query feature. So what is query? A query is another very simple object. A query has a table that backs it, and then it has a bunch of filters and an optional sort. What's a filter? It's a thing that takes a row and gives back a Boolean. What's a sort? It's a thing that takes 2 rows and gives you back a number, which is what the compare functions do. Okay, now what happens if you ask for a list of rows from a query? Well, the first thing that happens is that we get the rows from the table, and as a reminder, that does this splatting thing. Then we loop through all the rows, and we make sure that all the filters match the row. And then if we have a sort, we sort the filtered things by the sort. Otherwise, we just return the array. So basically, it's a little object, wraps a table, has some filters, and gives us back new rows. Okay. So that's the table, that's the query. And then we have a little people class. So what is a people? Well, it has a table of person, it has a query of person. And then what happens if you get the table, it gives you back the table. If you get the rows for a people, it gives you back the query's rows. And then there's two convenience methods for adding sorting and filtering. Let's look at filter first. So you can filter based on text. What it does is it takes the existing query, it adds a filter to it that checks if the row's name includes text or the row's location includes text, and then it returns a new people object with the table and the query. Then what does the sort method do? It takes a column, so that would be like name or location, and then it takes a locale. The reason it takes a locale is because we're going to want to use the Intel API to sort things so that we get the right behavior for different languages. And this looks like a lot of things are going on here, but really all that's going on is we're making a new collator for the locale that we passed in, and then we're making a query. We're giving query a sort, which is going to get the values out of the column. So let's say we're sorting by name, so we're going to get the name out, and then we're going to use the collator from Intel.collator to compare, and gives back a new people so that when we go to get the rows, does the right thing. Now, here's the most important thing. You didn't have to follow necessarily all of that, but the thing to note is that there's no reactive concepts in here, right? This is just an object. Everything like locale is just a string. There's nothing about hooks. There's nothing about needing to run something multiple times. There's no special kind of objects that you need. There's no piping, right? There is one place that we've seen so far where we have a reactive object, which is right here, this reactive map. But other than that, all we've seen so far is just functions that work with that, ultimately that underlying map, and produce new values. Okay, so that's basically how the data works under the hood. And now what we're going to do is we're going to go look at our app. So we replaced the app already with the unfinished data table, and now let's take a look at the component. So the first thing that you're going to notice here is that we have this use starbeam hook. And use starbeam is basically wraps your entire component, and its job is just to get you into starbeam mode so you can access and work with all of the reactive data. Now, inside of starbeam, inside of a use starbeam component, there's two sections. There's the top section, everything up until the point where you return this JSX chunk. So the top part of a use starbeam function runs exactly one time, and it's a good place to set up stuff like this table that you only want to set up one time, or functions that you don't want to have changing under you. And the bottom part, this callback, this chunk of JSX, that's the thing that runs over and over, so that React has JSX to reconcile. But the critical thing here is that starbeam makes sure that it doesn't rerun if none of the dependencies, the reactive dependencies that are used inside of the callback run. And we'll see what that means in a minute. You can sort of think of it as a React.memo on steroids. Okay, so let's take a look at the actual implementation here. So we have a JSX, we have this form here, and you'll see, if you run the form, you can see that the form doesn't really work, right? Because if we look at what the append function does, it doesn't do anything. So we'll take a look at that form in a second. Then we loop over all the columns on the table, and just remember the columns are just a field that's on the table, and we turn them into THs. And then we have one last TH here that gives you ability to clear all the rows. And that's what happens, right, if I clear all the rows. We'll talk about that in a second. Then I loop through all the rows that I have, and for each one, I make a TR, I give it the key of the ID that we created, and then I give it TDs for the person, the name and the location. And then I have one final action here, which allows me to delete the person.id. Now, I just want to reiterate, when you look at clear, that's just doing rows.clear. When I do table.delete person ID, that's just doing rows.delete ID, right? So even though these are callback functions that are happening inside of here, they're happening inside of JSX, you didn't have to do anything fancy here. They're working with starbeam data. Okay, and then finally, we have this summary section over here. And the summary section has a data items attribute of the length, and that's basically so that when there's 0 of them, there's some CSS that makes it look different. And then we have a TD, which prints out the total. And what is the total? Right now, it's very simple. It just says items, table.rows.length. Okay, cool. Now, what I want to quickly look at here is, so we already have some interesting data here, right? If I reload and I start deleting things, you can see that there's already items 2 here. You can see that the array got filtered and stuff like that, right? And so how did that happen? What exactly happened here? So notice that we don't have any kind of use state. We don't have any dependency arrays. We're not using React concepts really at all. So how does that work? So the way it works is that if we go back and look at our table, like I said, there's this little piece of reactive state here. And when you get the rows of the table, it gets this.rows.values. And Starbeam knows that when you do this.rows.values, that means that you are reading the iteration of the whole map. And that means that whenever anything changes the iteration of the whole map, that will invalidate the read of this.rows.values. Okay, but the thing is, we don't actually use the table rows directly most of the time. What we mostly do is use it through other abstractions, and we'll see that's going to get more and more elaborate over time, right? And so the point is that it doesn't matter if we specifically use people.rows here or if we use it through something else. The fact that we access the data that is inside of people.rows somehow. So people.rows, just as a reminder, is not actually directly, it's not the table, it goes through the query, and the query, as a reminder, goes through the filter, right? So there's actually a lot of steps in between what looks like, oh, it's just the rows, and that piece of state. But you don't have to say anything about that. You are able to just write normal JavaScript code here. Okay, so that's great and all, and what that basically means is that when we say table.delete person.id, Starbeam knows that this people.rows.length invalidated, and therefore it knows to re-render the template. Not the template, the JSX. So what's the next thing we want to do? Well, we have a non-working form here in this append, so let's go and implement it. So the thing we have right now is we just have e.prevent default. Let's take a quick look at the form. So we have a form here, it has an onSubmit, and then we have input type equals text, name equals name. So we're using the HTML way of giving it a name. We're saying it's required. There's some CSS stuff here for errors. And the second input field has a name of location. We have a button type equals submit, right? So that just means that when we hit enter, we hit tab and space, we click whatever it's gonna hit, it's gonna call the submit. So what do we want to do with that? Well, the first thing we need to do is get the form out of the event. And the second thing we're gonna do is we're gonna make a new form data out of the form. Now, if you don't know what a form data is, it's pretty interesting. What it basically does is it takes the form, it gets all the names of fields that are valid, in other words, non-disabled fields and stuff like that, and it turns it into an object that has those keys and those values. And what's really cool about form data is that it implements iterable of entries. So you can just say object.from entries of a form data, and you get back something that looks exactly like what you would expect, right? So it's a little bit of incantations here, but we take a form, we make it a form data, we do object.from entries, and we get back this. We get back an object that has a name and location, which is precisely what we want, right? We want our table has an append on it. The append takes columns, which is the name and location, right? And when we're done with that, we're going to reset the form so it empties out what we already did. Cool. So at this point, we would kind of expect it to work, I think, right? So let's check. So I'm going to add Leia Silber, and I'm going to add Portland, and it worked. Great. And so why did that work? Like, what exactly happened here? So what basically happened is that when we clicked on table.append, that set a row on the map, right? On the map here. And because other parts of that same component read from ultimately the this.rows.values over here, which is an iteration, the fact that we added something to the map means that it invalidated anybody who tried to read, anybody who cared about the iteration, right? In other words, because at some point I computed a list of all the keys and the values, if the keys and values change, then anybody who read the list of keys needs to recompute, right? So the fact that I called append, it looks like, you know, I'm just mutating an object, but behind the scenes, Starbeam keeps track of every read, every write, and links them up together. Cool. Okay, so now that we did that, the next thing we probably want to do is implement the filter. So in order to implement the filter, we're going to need a cell. So a cell in Starbeam is just a very simple object that is a space for storing one thing, right? So we have a cell here, and it's a space for storing a string because the filter is going to have a string in it. And we're going to want to make another field here. That's just going to be our filter. So what does that field look like? Well, it's going to have a default value of the current filter.current. And so filter.current is reading from that cell, right? So that's a thing, it's a reactive thing, it's reading from the cell. And what happens when the What happens when you type something in? No problem, we set the filter. So filter.set is how you modify a cell with the value of the current target, right? So now if I type something, I was able to type in the filter, but we didn't do anything yet. So we still need to do something here. So in order to make it useful, we don't want to just make the rows just a bunch of rows. We want to make a query, right? So what's going to be the query? The query is going to be the people table that we have, and we're gonna use that filter function that we wrote before to filter based on filter.current. Now note, just accessing filter.current in here is enough to know that we're accessing the underlying filter. So we have a function here called query. It's a regular function, nothing special here, and we're making a new filter. We're making a new query which filters by the thing we typed here, and we're also going to sort by the locale for good measure. Okay, so now that we did that, we're just going to update the rows here to return the queries rows instead of the tables rows. And now if I type something, Portland, Yehuda, right? If I type Chirag, if I type NYC, right? All of that worked. And so why did that work? Well, part of why it worked is that the filter does this somewhat complicated thing, right? It goes and for each row, it checks if the name or location includes the text. And when we said query.rows, that's the thing that actually went ahead and ran the filter, right? So again, this is just pretty normal JavaScript code. And all we did was make a new function here called query. And all we did was make our existing function rows use the query. But the fact that this code down here, the code that loops over says rows, the fact that that accessed the query, what does that mean? Well, it means that it means that it has a dependency on two things. It has a dependency on this filter thing, and it also has a dependency on this rows thing, which has a dependency ultimately on the table rows, right? Which is this iteration, right? So basically, just the normal way of accessing, the normal way of writing code here means that our computation of rows here caused Starbeam to know that this whole component depends both on the filter and it also depends on the rows. Okay, so one thing that I think is worth noting here is that there's surprisingly few pieces of root state here for a pretty complicated setup. So we're gonna add one more feature here. What we're gonna do is we're gonna make it so that if we filtered something, we want this to not say items for, we want it to say items some amount of filtered over for, right? So how are we gonna do that? Well, we're just going to replace this total function here. The first thing we're going to do is we're going to get our rows, and that's going to be the amount of rows that were in the query, right? And the second thing we're going to do is we're going to get the total number of rows in the table. Now, if the two things are the same, the filter count and the total count, we return what we had before. Otherwise, we say items filtered count filtered over total count total, right? So if we just reload the page, obviously nothing happened here. But if we start filtering, we say Chirag, we say NYC, we can see it worked, right? And once again, this total function has a dependency on rows. It has a dependency on table.rows, right? It has a dependency, and what does rows have a dependency on? It has a dependency on the query, which has a dependency on the filter, right? So all this is just a pretty natural way of writing normal code without having to write anything special, without having to say anything special about how things are connected to each other. And it all sort of works out. Okay, now I keep saying things are dependencies of other things, but you sort of have to imagine that. But let me show you a little debugging tool that we have that lets you see it more explicitly. And to turn it on, we're just gonna grab the logger from Starbeam. We're gonna grab the logger from Starbeam debug. We're gonna say logger.level equals log level dot debug, okay? And now once we do that, if we open up the dev tools, we see that we're starting to get some additional information. It's showing us that this use Starbeam block, which is located over here, let's pull that down. You can see exactly where it's located. It tells you that that has a dependency on this cell, has a dependency on this map. I'll make it a bit smaller. Okay. Now the next thing that we can do with this debugging tool is if we invalidate something. So let's say we go back to this filter here and we say C, right? what we're going to see is that it tells us that use starbeam invalidated and tells us exactly what invalidated, which is this cell here. And it gives us a link to exactly this location. Now, this is a little bit noisy. And so built into this setup is a way of saying for each new piece of root state, you can give it a name, right? So here we can say cell, we can give it a name of filter, right? And we can go to our table and we can say, I already did it. I gave map a name table, right? And we can go to, I think those are the only pieces of state, right? So now if we look at it, we'll see that it says, it gives us the names instead of the very long words. And if you wanted to turn it on and you want to see the stack traces anyway, the longer links, so you can click on them, you can just always turn it on to trace mode. And that will give you the links no matter what, right? So you open it up and you always have these links here. Great. Let's turn that off. Okay. Now we have one last feature that I want to implement, which is so far everything is self-contained inside of Starbeam. But like we said, this is inside of a React app, and so we really would like to be able to have this component take some arguments from React. So in this case, what I want to do, instead of just using the system locale as the sort, I want to get the locale from the React app. Okay, so in order to facilitate that, I created a locale switcher here. So we're just going to implement it using a pretty normal React pattern, right? We're going to use state. We're going to, I'm just going to grab some stuff here. I'm going to format the locale, but it's a select box, right? It sets the state. And now that we did that, if we turn it on over here, right? And we can see that we have the select box. And what we would like to be able to do is just pass the locale directly into our component. And of course, there's no reason why we wouldn't be able to do that. This is just a regular React component. So we can say props locale string here. But there's a bit of a problem here, which is that the way React works is it's just going to keep calling this function over and over and over again with new props, but Starbeam doesn't really have any idea what that's about. And so we really need a way of turning this locale into something that Starbeam understands. And for this kind of situation, there's a hook that we provide called use prop. So we can say const locale equals use prop, props.locale. Okay, and we're going to pull in use prop from Starbeam React. And now all we got to do here is we just have to change system locale to locale.current, right? So that just shimmed the React world into the Starbeam world. And now here's why I set it up this way. So this umlauted word name is differently sorted in Swedish and other languages. So let's switch to Swedish real quick. And ta-da, as you can see, it's now sorted at the bottom. Let's bring back up our dev tools. And now what we can see is that we actually have three pieces of state here. We have the cell, the filter cell, we have the prop, and we have the map that we've been talking about the whole time. And just like anything else, we can give this a name. So let's just call it props.locale for convenience in our debugging. Right, so now we can see, okay, we have those three things. And now if I go and select Swedish, you can see that that is exactly the thing that invalidated it. Right? And if I was to instead type in like NYC or something like that, what we can see is that now we know the filter is the thing that invalidated it. Now this is still a pretty early debugging tool. This is just a logging for convenience. We would expect some more elaborate debugging tools eventually built on this infrastructure. But the basic idea here is that from Starbeam's perspective, this function over here has dependencies of just three things. Now, one of the things, the map is a little bit of an elaborate thing so that we can do more granular tracking. But in general, there's only three pieces of root state. It doesn't matter that we have this total function. It doesn't matter that we have this rows function. It doesn't matter that when we go in and look at this rows thing, it's doing this going through multiple steps, it's doing this complicated filters thing. None of that matters. At the end of the day, the only thing Starbeam actually cares about is that it has a dependency on filter, it has a dependency on the props, it has a dependency on the map, right? And whenever we go and change something, let's go create a new person, right? So let's make a new person. It's we'll make Leia again, and we'll say PDX, right? What you can see is that the thing that invalidated is the map, right? So at the end of the day, even though there's a lot of complexity here in your code, that complexity is all in very standard normal JavaScript stuff. And the reactivity is really just saying that this callback here, this thing that generates JSX, has a dependency on three things. It has a dependency on a map, on the iteration of the map. It has a dependency on a filter, and it has a dependency on the locale prop. And now all Starbeam has to do is keep track of those three things. Whenever they change, it invalidates and notifies React and invalidates. The nice thing about this is that if you have a lot of components in your app that use Starbeam, each individual one doesn't invalidate any of the other ones. It's like I said, it's kind of like a souped up React.memo. So what happens is, without you having to say anything, simply by accessing values using normal functions, using normal getters, using normal methods, using normal access patterns, you're telling Starbeam exactly what the dependencies are. And Starbeam is able to keep track of exactly when it needs to invalidate. And you can shim into the React world pretty easily too if you need to, and that works totally fine. Now, one thing that's pretty cool, I think that the last thing I want to say here is, if you go back and look at our table, there's no actual imports from Starbeam React or from React, right? And that's because this code, this table code, this query code, this people code, this is all pure Starbeam stuff. And that means that this exact same code will work in Svelte, it will work in Vue, it will work in Ember. And that's pretty cool. It means you can start writing libraries that are kind of like this toy example, but bigger, something like a GraphQL library. And you can write it mostly in Starbeam concepts, and then expose it to React, to Svelte, to Vue using these adapters. You don't have to build universal code with Starbeam. You can just build stuff inside of the React app, but you also could build these universal libraries. And I'm pretty excited to see what's going to happen once the ecosystem has the ability to start writing reactive code in a way that's decoupled from individual frameworks. I think that's going to be really awesome. If you're excited by this, definitely come check it out. You can come to our Discord, you can come to our GitHub, you can start, you can like it, you can submit issues, you can try to integrate it, you can try to do some work, you can try to help with debugging tools. There's so much stuff going on. I'm pretty excited about how far we already got, but there's still a ton left to do. And if you're the kind of person who likes getting in on the ground floor and making a run for something, great, join us. We're excited to have you. Thanks so much and enjoy the rest of your conference.
That was a super insightful talk, and I hope that everybody joins the spatial chat to chat some more. Another word from a platinum sponsor, AG Grid is a customizable data grid that works with React, Angular, Vue, and Vanilla.js. The grid is super fast and can easily handle over 100,000 rows and high-frequency updates. And our next speaker, Hemant. Hemant is a TC39 delegate working on JavaScript feature proposals. His talk will be walking you through the potential JavaScript features that are cooking right now. Hemant will share some code samples and some insights from the TC39 meeting notes. Please go to the community track, to cheer him on. We're looking forward to his talk, and feel free to leave your questions there as well. Hemant, the stage is yours.
Hello, JSNation. Welcome to the future features of JavaScript. In this talk, we will be going through different proposals from stage 0 to stage 3, understand why they exist, what they're trying to solve, and hopefully they get implemented in all of the JavaScript environments. I'm Hemant. I'm an engineering manager here at PayPal, a TC39 delegate, a Google developer expert for web and payments domain. You can hit me at Gnumonth on Twitter or find me on htman.com. The ECMA International has a lot of technical communities, out of which TC39 happens to be the ECMAScript community, which is responsible for the specification that JavaScript implements. The TC39 process includes different stages, starting from stage 0 to stage 4, which stage 4 is finished and implemented in different environments. And stage 1 is more like a straw man with just basic idea of what the proposal is. In this talk, we will go from stage 0 to stage 3 and see different proposals. If we look into the current state of how the proposals are, on stage 0, we have 18 proposals. On stage 1, we have 91 proposals. And stage 2, we have 22. And stage 3, we have 17. And stage 4, we have 59 proposals. Let's dive into and surprise ourselves with some of these proposals. Starting with stage 3. Say we have an array of objects and you want to find a particular value from the end of the array. What would you do? You would probably do a reverse on that array and do a find. In this case, we are trying to find the values which are not divisible by 2. In this case, we got value as 3, but we had to reverse the array and then do a find. What if we had a convenient method which says array.find from last, array.find last, here is the condition and give me the element. What if you were to find the last index? You would again do a reverse and do a find.index and take the array.length and subtract -1 from it and subtract that value from whatever we found if the result is matched to find the index. In this case, the value was 2. Suppose the condition is not met where we are looking for number 42. The value should have been -1, but it is 4. What if we had a method which said array.find last index, and when the condition is met, it would find the index if it's present, and if not, it would give a -1. Wouldn't it be convenient? Here on the left is a comment from one of the issues in GitHub for this proposal, where the idea was to discuss and come up with names. As you can see, some of the names that were popped up in the issue was like find right, find index right, find last, find index last, find end, find index end, and so on. And finally, we have find last and find last index as the proposal today. On the right side, we can see an implementation from the Chromium source, which says fast array find last. If you were to open up the spec, you could do a one-on-one mapping to each of those lines in this code to understand how the specification is implemented. For example, on the comment where it says 4, that's point 4 in the spec, which says let k be length -1. And that's where we have the exact implementation here. And that is find last and find last index. Then we have import assertion. This kind of proposal gives a way to assert the type that we're importing. For example, in this case, we are saying import JSON from foo.json, assert type JSON. We are saying, okay, this is of type JSON. And if you were to use dynamic imports, you would say import foo.json and say assert type JSON when you're doing a dynamic import. And if say you have a JavaScript, which is kind of exporting a value and you want to export that value from your file, you could say export value from foo.js, which is exporting that value. And then you're asserting type to be JavaScript. And finally, you could use type to be WebAssembly. And this can also be used in the script tag. And you might be wondering, why should I use an assert type, right? Why do I need this inline thing? Why not just import JSON from foo.json? Well, it happens just relying on the MIME type to figure out whether it's JSON or not causes a security bug. There's a lot of concerns around security on just importing a random file, right? And then you have to make sure that you're asserting this is of type JSON. And if it is something else apart from JSON, it would throw and say, hey, I don't know, because I'm trying to assert this to be a JSON file and it's not, thereby keeping the code more secure and giving us an easy way to express ourselves inline on what type is this in terms of asserting that this is what we are really importing. Similarly, we have JSON modules, which is very much similar to what we saw previously. You can import JSON as modules and having this assertion type. But you might be wondering, why 2 different proposals? Is it very much similar to what we just saw previously? Well, if you dig into the notes from the meeting, you can notice here that there was a discussion and a decision that was made, which said one of the decisions was that to decouple JSON modules so that it makes into stage 2 and then progresses to different stages, right? This is a common thing that happens during the phase of a proposal. It might get modified, it get changed, can branch into 2 different proposals. It can also get discarded and rejected to a lot of reasons. So here we saw that JSON module was part of the import assertion, but become an independent proposal in itself, and so that it can accelerate quickly towards the finish line. Definitely don't miss this talk from Yulia, which is part of JSNation this time. And she's talking about how JS modules work from a browser's perspective. She's a TC39 delegate, of course, and as an implementer in Firefox, this talk is must watch if you want to know more about how JSON modules work. The other proposal we have is change array by copy. As the name says, you're changing an array by copy. Let's see some of the examples here. Say you have a sequence, an array which 1, 2, 3, and then you say 2 reverse. Of course, you get 3 to 1. But interestingly, the sequence remains the same. We are not mutating the sequence. And that's where it's super useful when you're not mutating the array, but still getting the reverse of the array. Similarly, you have to sorted, where you want to sort, say, in this case, you went 8 arrays, and you could say out of order to sorted, you get the sorted array, but the original array stays as is. And we have the with method, where if you want to make a change to the array, in this case, the correction needed is the array where we have 1, 1, and 3, and we want to have 42 in the index 1 rather than 1. So we say correction needed with 142, we get 142, 3, but the original array remains as is, that's 113. Say you want to splice, you could also call the to spliced. Here we have 2 on, so we get 5410 from an array which was 543210. So we splice that, but the input original array remains same and is not changed. And this is a very convenient method. We have array group by and array group by to map. Let's say we have an inventory with veggies and fruits in this example with different quantities. Then you could just say inventory.group by type, and you get an object which has the keys as fruit and veggies, and the values are array of the respective values from the inventory. Then we have inventory.group by to map, which does very much similar to what group by does, but it returns as a map. So we can do all the map operations on the return value. Unlike inventory.group by gives you an object, here you get a map. So this is for convenience, so you could do all the map operations. And this has many use cases, and this is super useful. Up next, we have stage 2. Say we have a generator which kind of yields multiples of 2. And if you were to convert that into an array, so what would you do? Today, you take an array and use an for of await syntax and use it on the generator and keep pushing it to the array, and then you would probably get an array. So basically converting that into an array. So what if we had an easy method? Array from async, you give an async generator, you await on it, and what you get back is an array. Wouldn't that make life easier with just this one-liner, which is super convenient? And yes, if you are thinking about promises, well, we could do the same thing as we did in the previous example. If your generator is yielding promises, and then you wanted to convert that into an array of promises, then you could just say async from array, generate promises, await on it, and you would get an array. This makes life very easy if you're trying to work on generators and async operators and trying to convert them into an array. So it's async from array. It's very much similar to array.from, where you could pass an object which is like an array and get it converted to an array if you give it a length. And similarly, it's an extension of that which says array from async rather than just array from and pass it to an object. Right? The next proposal, what we have is throw expressions. Say we have a function which says save, and it is receiving a parameter. And what if the user doesn't pass in a parameter, or what if the user passes in a parameter that you don't want them to pass? You would probably check the type and do all the required assertions and then throw if it's not matching your expectation. What if this can be done as an expression in line? In this case, you say file name equals throw new error, type error argument required. This would throw automatically if that argument is not passed into the save function, right? Here, you could also have it within the arrow function bodies. In this case, you have an abstract syntax tree AST with lint, which has a with method as one of its keys. If someone's trying to use the with method, then you could just throw saying that, hey, avoid using the with method, with statements, right? Then you can also use it in logical operators. Say you have a getter and setter within the class. And for setter, you would say if the value is not passed, then you could throw saying that invalid value, right? If it's not the value that you're looking for. And you could also use it in conditional expressions. And if all your conditional expression exhaust, you can just throw a new error saying that unsupported encoding. In this case, you have like different encoders from UTF-8 to so on. That is throw expressions. Records and tupules are one of the most important and interesting proposals in the recent past, which kind of brings in immutability to JavaScript. So we all know when we do strict equalities of two objects with the same key value pairs, they are false. Even the same holds for arrays with the same values, but we do a strict equality, it is false. But if you have this syntax where you have a hash followed for what looks like an object literal and even hash followed for what looks like an array, they both equate themselves to be true. And that is a record and tuple, where you could say type of hash which looks like an object which is immutable is a record, and type of hash which looks like an array which is immutable again is a tuple. So if you have an object which you want to convert into a record, you could just call it with the record constructor and you would get the record back. Or if you have an array which you want to convert into tuple, you could say tuple from, pass it an array, and you'd get a tuple back. And definitely do watch Robin Richards' talk on records and tuple immutable data structures in JavaScript, where he goes in detail, also a TC39 delegate. And this is a part of the JSNation talk series too. Next, we have the pipeline operator. Say we have this example, which is console logging chalk.dim, object.keys of environment variables, mapping over environment variables and taking the key value pairs and joining it, finally joining the entire args to kind of create an output. Isn't this bit confusing? Like, let's see how the brain probably would try to evaluate this. It would say object.keys from left side, then we have map on the right side, and we have join on the right side, and the template literal on the both sides, the tilde characters. And then we have chalk.dim, and then we have console log. It's a lot of nesting and convoluted code. What if we were to make it more easier, right? Let's see this example where it says object.keys of environment variables, map the environment variables, return me this string, and then join. And then you have this strange looking syntax, which says pipe, and then it says $% where percentage basically is the value that evaluated in the previous step. Then we say chalk.dim percentage, again that percentage is replaced by the value that was evaluated in the previous step. And finally we console log percentage, that's the value that's evaluated in the previous step, thereby making it easy to read and understand, also to chain different methods. And that's the pipeline operator. There were two competing proposals for pipeline operators, hack and F# pipelines. But there was like another third proposal, which was kind of a smart mix of these two proposals, but that has been withdrawn. This is what we have currently today for the pipeline operator. Map.emplace is another interesting proposal where, say you have a map and you want to check whether the key exists within the map or not before setting it, which is a common use case, right? You would say if not map has key, then map.set key value, then you do map.get and do things. What if it could be more simpler and you say map.emplace key insert value, do the thing, right? It would basically check if that key is there or not, and then insert. And probably would have also done this. Map.get get the old value. If the old value is not there, then set the value, else set the updated value. What if we could avoid these two lookups and make it more simpler? You could do map.emplace and put a key there, and you have update and insert methods within emplace, and you could operate based on your use case. And map.emplace makes it more simpler in avoiding those extra lookups. Iterator helper is a large proposal, and let me try to fit it in this slide and see the different things that iterator helper provides. Right, so say you have a function which is a generator function which kind of generates all the natural numbers, and of course if you do result.next you keep getting those numbers. What if you were to do a map on this iterator? Yes, this proposal talks about it. You could do a map. You want to do a filter? Yes, we could do a filter. And here's an example. You have an async iterator from URLs. You get an async iterator, then do a map on it, then do an await fetch, and again get the response JSON, and finally do a to array. So you have an array of all of those responses as JSONs, right? And then if you want to do a take, if you want to be a bit lazy and just take only 3 of them from those huge series that this generator is providing, you could do that. If you want to drop 3, you could do that. If you want to have if you do dot values, you get that iterator, and you want to do as index pairs, then you get an index pair that would be like a 0x and 1y and 2z and so on. Right, and then you could also do a for each, every, sum, find, all of this on values, and that's iterator helper, where it makes life easier to iterate over all of these different methods on and having async iterators on that. Now we have stage 1. say you have an array of A, B, C, D, and you want to do array.slice 1, 3. What do we get? Is it BC or BCD? Say we have an array of A, B, C, D again, and we do array.slice. What do we get? A, B, C, or D, right? Well, this can be easier with slice notation, which is a bit intuitive, where we say array 3 colon, that means give me D. And if I say 1 colon 3, that's 1 to 3, that's BC, give me BC. If array of -2, start from the end, give me AB. Array of -10, which is out of bounds, give me an empty array. So if you were from the Python land, you would have probably used this a lot, and many other languages do provide this facility, and it would be super nice to see this in JavaScript. Type annotation is a big proposal and created a lot of noise in the public domain, and too many people are interested because of how people are used to TypeScript these days in terms of using type. Here's what the proposal basically is about. If you're used to JSDoc, you would probably have used something like this, where you said, hey, here's my strings function, right from the readme of the proposal, where we have P1 as a param, which is a string, and P2 is a string, and so on. And this is how you would probably put it in your JSDoc. And with this proposal, it looks very much similar to the TypeScript syntax here, where you would say P1 is string, P2 is optional, where it's a string, and P2, P3 is optional and string, and P4 is defaulting to test, and this function returns a string, right? So type annotation gives us this kind of a syntax where you could add the annotations to your methods, and it's an evolving proposal, and it's very interesting to read about the details. Next, we have array unique by. As the name says, say you have an array of, in this case, we have 1, 2, 3, 3, 2, 1, and we do an unique by, we get 1, 2, 3. But it gets interesting if the array has objects, right? And you want to do unique by UID, then you could do that. Or you want to do a unique by which takes an ID, UID, you want to do those pairs and probably get unique by, you could get that too. So unique by is a very convenient method to do kind of get unique values from an array which has duplicates. Number range and big int range is a proposal that kind of gives this range method on big int and numbers. See, in the first example, we have an for off loop where the big int range starts from 0n to 43n, which kind of logs 0 to 42n numbers. If you are referring to the iterator helper that we previously saw, where you can do a number range from 0 to infinity, take say 1,000 of them and filter the numbers that are not divisible by 3, and then do a 2 array, you would get those numbers. Or say you have a generator which generates just even numbers from 0 to infinity, and you just want numbers from like get all the odd numbers from say 1 to 99. You could do number range 1 to 100 of 2, then you would get those. So that's the range method on number and big int range. Function one is in other proposal that's interesting. Say you have a function that you want to execute only once for various reasons. And then say in this example, you say function once, and you say f.ones as f1s, and f1s of 3 would print 3 and return 6. That's the console log that's there in the function. But again, if you call the same function f1s with 3, it doesn't print anything but returns 6. f1s of 2 also returns 6, doesn't print anything, right? So it's just execute once, and if you keep executing it again, you just get back the same value that was evaluated when it was invoked for the very first time. There are some interesting discussions in the issue for function ones. Say you have a function which is a recursive code, and you do a g.once, and then you call g once, what should happen? Or say you have a function g of x which does stuff which takes a lot of time and has async operations in it, and then you say async g once and you get promise 1, and you do async g once again, you get a promise 2. What should happen? So these are some of the interesting discussions that happens in proposal, and it's a good practice to go and read the issues and try to dig and understand what's happening, and we could also contribute with your opinions. String.cooked is another interesting proposal where say you have an Unicode sequence here for say U61, you do string.draw, you get the same thing back. You do a string.raw and then pass in an object which has a key raw and which has an array of value of that, the Unicode sequence, you would get an A. So if you do a console log, and you would probably get A for this Unicode sequence. What if we had string.cook instead of saying string.raw with passing in an object with raw as its key and the value being an array with that value that you want to kind of convert it into a string? Well, it's complex, right? You might sometimes miss that there is this property with string.raw that it behaves in a way if you pass an object with raw as its key. Rather, if you had string.cook and just passed /u61, we would get A. So that this proposal makes it simple and make your code less error prone while you're operating with string.raw. Do expression is one such proposal which makes things simpler in evaluating and assigning values to say return values or to variables. In this example is a JSX example where you have a do expression which says if logged in, then return a logged out button. If else, you return a login button. This is a pretty common construct in JSX, right? You would probably use a conditional operator or try to return this component. Here, we are just putting a do expression that evaluates, and whatever is evaluated to true is the value that it returns. Let's see another simple example here. Say we have let x on a do expression, and we say let temp is the function call, and then we say temp into temp plus 1. So temp into temp plus 1 is whatever that evaluates gets assigned to the variable x. Similarly, if you have x do with if, else if, and else, whatever condition matches, and whether f or g or h method is called, whatever the return value of those method gets assigned to x, thereby making it more simpler in terms of assigning the values to the variables when there is a nested construct and there are too many things to return and evaluate. On a similar line, we have async do expression. Say we have async operations within the do block. So we could say async do and say fetch a thing and return a JSON response, and fetch another thing, get a JSON response, put it in promise.all and evaluate, and you get back the results. Pattern matching is another interesting proposal where, say, you are fetching some JSON service in the example, and you get a result, and you do a match on matchable, and then you say, when, say, my status is 404, I could say JSON not found, or I could just pick up the status and do a check myself and say if status is greater than 400, then throw a request error, and so on. And partial application, if you're into functional programming, then you would really know what a partial application is. Say you have a function which takes n number of arguments, and you're passing partial number of arguments to it rather than passing everything, and later on you would pass in the other argument as your function progresses. And in this example, you could do a partial application from the left, or partial application from the right, or you could do a partial application of any argument, right? And that's where partial application comes into action, and the question mark is the placeholder which says, hey, this argument will be passed on later on. Finally, we are on stage 0, where we have this bind syntax. Say we have object followed by the double colon, which is the bind syntax, and function, which basically is equal to object.function.bind object. Say if you were to use console log as a variable few years back in the history, you would probably do a console.log bind console so that the object is bound to the right context. Similarly, if you have object followed by this bind syntax function value, which is equivalent to function.call object value, and if you were to use the this bind syntax object.function value, that is equivalent to saying that object.function.call object value. So let's see a quick example to make it much simpler. Say you have an iterator library which gives you map, take while, and for each. And we have a get player function which kind of gives you all of the players, and you're mapping through those players. Even though if it's not mappable, you do a map.call and then get the characters. Then you do a take while.call and get the strengths which are greater than 100. And then finally do a for each.call to loop over them and console log. It would have been more simpler to use the this bind syntax. You would say get player, this bind syntax, map it with x.characters, bind it with take while again, get the strength, and do a for each. So everything is bound properly, the execution context, and you get the value that you're expecting. The final one, what we have is string characters. Say we have a string with dash underscore dash ABC dash underscore dash, and the characters we have is a dash and underscore. We could say string.trim characters that would find all of those characters and trim it off. So we just have ABC. And then we could do a string.trim characters. You could do a trim start that would just do, trim the characters at the beginning. So the dash underscore dash is gone. And what we have is ABC underscore ABC dash underscore dash. And if you do it from the end, the dash underscore dash from the end is trimmed off. So that is string trimming of characters. That is all we have, folks. And hope you liked all of the proposals. And I'm super excited about these proposals and hope all of them make it to different JavaScript environments and we reap the benefit of it. Thank you.
That was super interesting, and I bet that everybody is running towards the spatial chats right now to have a further discussion. Also, don't forget to join the discussion room on landscape of various JavaScript engines with Google's Sarah Drossner and others. A quick word from our gold sponsor, Focus Reactive, which is a Next.js headless CMS and an e-commerce expert agency. Partnering with Vercel and Sanity.io, they deliver quality software with a focus on scalability, performance, and great user experience. And for our next speaker, Stuart Smith. Stuart is the creator of QJS, an open source drag and drop quantum circuit composer. Now, doesn't that sound intriguing? Join Stuart Smith as he explains what the heck a quantum computer really is, what it's good for, and how to use quantum JavaScript in that context as well. Go to the community track, cheer him on. You'll find Stuart there as well, so feel free to leave your comments and questions there. Stuart, the stage is yours.
Hi, I'm Stuart Smith. Some of you folks might already know me from my day job. I've been part of the virtual reality community for quite some time now, particularly the web-based VR community. I got involved in web VR back when building web-based virtual reality meant asking Brandon Jones over at Google for custom builds of Chromium. The medium felt really fresh and exciting. And around that time, I wrote the VR controller library for Three.js. It provided an easy, generic way for your web VR app to support a bunch of different hand controllers without having to write custom code for each one. So back then, that meant, the first Vive controllers, Microsoft Mixed Reality controllers, Rift Touch, Daydream, remember Gear VR, and all that stuff. Over at the Google Data Arts team, we used the VR controller library to power this VR music video for the band LCD Sound System. You could dance along to the song in VR, and then a recording of your dance would become part of the video itself. So shout out to our collaborators and the real stars of that project, Studio Moniker and Studio Pucky. Look them both up. I also released Space Rocks, a personal tribute to Atari's 1979 classic Asteroids, but in VR, of course. I took my VR controller library and I added something I called multi-channel haptic feedback, which made it super easy to add complex haptic commands to your web VR app. Like if you wanted kickback from firing your laser, but also needed to feel the hum of your plasma engines revving up and down, well, my haptic channels approach made that a breeze. And just a few years later, Oculus upped the game by adding a hand tracking API for web-based VR. I immediately wrote Handy.js for both recording and recognizing hand poses on the fly. So instead of just pinch gestures to select things, with Handy.js you could easily recognize the whole ASL finger spelling alphabet, and then some. Finger guns was most fun, obviously. And this library does not require any machine learning whatsoever. Seriously, there's no network inside of Handy. It's just some k-means clustering magic, and it is wicked fast. Now, I've made a lot of work outside of VR too. I started coding when I was quite young, but I'm educated as a graphic designer and artist. I didn't study computer science. I've worked as a commissioned artist, and I've had artwork exhibited in various galleries and museums. I'm also a lifelong mediocre to terrible musician. I even enjoy writing essays occasionally, despite having no license to do so. And right now, I'm the head of consumer augmented reality at Unity. Everyone knows Unity, right? Our game engine is all about providing real-time 3D rendering for the masses. 70% of the world's mobile games are made with Unity. And we're not just 70% of mobile, we're half of all games. So if you play games, you've played something made with Unity. But I'm not here to talk about any of that. I'm here to talk about my nights and weekends passion interest, quantum computing. I'm the creator and maintainer of Quantum JavaScript, or QJS for short. And I'm the founder of Open Quantum Club. What is this stuff exactly? Well, let's go deep on QJS for a second. It's actually a few things at once. It's this website and the corresponding source code repository. It's this drag and drop circuit composer interface in particular. It's a quantum circuit simulator. So all the inner workings that allow you to run quantum circuit simulations right on your phone or laptop without having actual quantum hardware in your hands. It's that entire code library and the corresponding API. It's the concept primers that are there to help you get up to speed on quantum stuff quickly, particularly if you're like me, no real physics background, no quantum background, just a casual coder with some high school math. It turns out that's all you need to get started messing around with this stuff. It's the documentation for the QJS API as well, because what good is a library if you don't know how to use it? And when you put all of this stuff together, there's the small but growing community of enthusiastic folks who've also fallen in love with this ridiculous idea of fusing quantum and web browsers, because JavaScript wasn't chaotic enough on its own already. And so for this community, I'm starting something called OQC, Open Quantum Club. This is a project that I'm spinning up right now through a website that will feature profiles and interviews with folks in the quantum community. The special focus here will be on the humanity behind the math. Who are the personalities? What are our collective hopes and dreams? So stay tuned for more about that as we head towards 2023. And okay, that's all great, right? But what exactly is quantum computing? What even is a quantum computer? This is a quantum computer right here. This hanging cylindrical tank that you see. There are different sorts of quantum computer architectures: polarized photons, trapped ions, superconductors. Right now, superconducting quantum computers, like you see here, are the most popular kind. They're used by companies like IBM, Rigetti, Google. Superconducting quantum computers require extreme cold to function, just a hair above absolute zero. So what we're looking at here is actually the refrigeration tank that holds the computing parts. So let's look inside that tank. And here we see someone servicing the parts that would normally be covered by the refrigeration tank during operation. This is what some folks call the golden chandelier. All of this intricate hardware inside the refrigeration tank is for supercooling and gently nudging electron pairs, using the quantum nature of this internal environment to represent data and perform computations on that data. And here is a glamour shot of a golden chandelier. I'm told that there is some actual gold plating in here for thermal and corrosion prevention purposes, but what we're looking at is actually mostly copper alloys. Still pretty though. And the actual quantum computation happens right here on this tiny chip itself, and it sits at the very bottom, the coldest part of the chandelier. This is where you actually nudge and measure the state of your electron pairs. And just to be clear, this hardware does not do some kind of magic. Our universe is already quantum in nature. We humans are just too big, and our environment is too noisy to be able to observe quantum effects directly. That's why we have to make really intricate hardware that can make these effects visible and useful to us. Okay, but you might notice this so-called computer does not seem to have a keyboard or mouse or even a monitor. It's definitely a computer, but not in the sense that we commonly use that word. It makes more sense to think about a quantum computer like a graphics card. If you're not familiar with graphics cards, this is one right here. You slot it into your computer's motherboard and it handles all the complex graphic rendering that your machine might need to do. If you're into high-end video games, you've probably been concerned about how powerful your graphics card is. Now, we never use the phrase graphics computer, though that's really what this is. It computes graphics. So we have a parallel situation here. A quantum computer is really a computing component. Instead of slotting it into your computer's motherboard like a graphics card, companies like IBM, Rigetti, Google, and so on, they hook these golden monsters up to the internet, and you can send them quantum computation tasks to carry out. They'll run your program, and then they'll send you back the finished results. And this paradigm has been around forever, right? Maybe you think of it as cloud computing or time sharing. When Pixar or Weta are rendering their computer-generated imagery for their next blockbuster film, they don't just render that on a single computer in the office. No way, it's too complex. Instead, they'll send that task out to what's called a render farm, racks and racks of raw computing hardware that you can access remotely. And that's the commercial model for using quantum computers today. Unless you're at a university or a major corporation, building this hardware yourself, you're going to write a quantum program right on your laptop or phone and send that over the internet to be run remotely on real quantum hardware like this. And then the results of that quantum execution will be pinged back to you when it's done. Now, we just talked about quantum hardware, and we'll touch on quantum hardware again in a few minutes, but I want to make something clear. Let's say this circle represents quantum physics. This is all the knowledge about how the universe actually conducts itself. Photons, electrons, locality, tolerances, thermodynamics, packets of light, and so on. And over here is quantum computing. This is just pure math and logic. You don't need to know anything about electrons or superconducting or any of it. This is just computer programming. Now, that statement might frustrate folks who understand both of these oceans of knowledge, but you don't need to know how electricity works to make a website, right? Same deal here. You don't need to actually know the physics in order to write some code. So all of that quantum hardware that makes up a quantum computer, it's really this intersection right here. That's actual physics and engineering in the service of creating a machine that can compute things. And that is great. It's all great. But this is really where QJS sits. I'm not a physicist. I'm not an engineer. QJS is not hardware, it's just software. So no physics, just computing. And if we're being honest, my personal knowledge scape looks a little more like this. Random puddles of knowledge rather than a vast ocean. But also this, because we humans are beautifully messy and nonsensical creatures. Learning is a journey, and I'm still at the beginning of my quantum journey, I think. If you think this stuff is exciting, but worry that you're not a physicist, that you don't understand quantum mechanics, all of QJS has been built so far on these splotchy puddles of knowledge. You're in good company. Hop in the puddles with me. Like I said, we'll touch on hardware again in a bit, but for now, let's talk about QJS itself. So this is the QJS website, really the hub for the whole Q experience. There are quantum tutorials, API documentation, and it's a playground for experimenting with quantum circuits. They're called circuits in the biz, so that's what I call them here, but it might be more helpful to think of them as programs, just code, just software. I'm going to play a quick demo video for you that I made a while back to show off some of the features of QJS. So keep your eyes glued to the video while I use this opportunity for a quick drink of water. Okay, all right, quantum JavaScript. It starts off with this interactive circuit building interface that runs right in your web browser. And I'll explain what these things are in a moment, but I'll just show you how it operates first. We can select everything and throw it away and start over. We also have an undo button here, which is great, and also a lock button, so we can lock our circuit and can't mess it up, can't select things, can't throw stuff away, which is even more helpful on a mobile interface where there is no hover state and selection. You're tapping. Perhaps you're tapping to scroll, perhaps you're tapping without meaning to, and you definitely don't want to mess up a circuit that you've carefully composed. But in this case, we can throw down an identity gate and maybe a poly-X gate and select them and combine them together to make a controlled gate here. And what we've just created here is a bell state. And even if you don't understand any of this stuff, you can see the live probability results being updated in real time as we change things. So it's really cool that you can drag and drop stuff together, but you can also code circuits with JavaScript. And what's even more than that is you can combine the two. So if we open up our JavaScript console here, let me clear it out. It says that this circuit is accessible in our console. And so let's give that a shot. Let's see. We get a circuit back. Here, let's make this a little larger. Let's see what that circuit looks like. We can get a diagram of it. It's not very interesting when we have a blank circuit. But here, we can quickly build that bell state again, and you can see as I'm editing the circuit, we're getting real output just like that. And here, let me scroll up. So we can actually see that this ASCII diagram looks very similar to what we have right here, doesn't it? And so that is pretty cool. And what's even cooler is we can start to do things like, let's say we want to add another one of those H gates, right? That's a Hadamard gate, and we'll talk about that in a second. Let's add it to moment 3 on wire 3, which should put it right there. Let's see if we can do that. Oh, and there it is. So we can actually jump back and forth between code and the drag and drop interface. So it's not about dumbing something down, not at all. With QJS, you have access to this quantum circuit both through code and the drag and drop interface, and you can fluidly switch back and forth to whatever has least cognitive overhead in that moment. Let's say I need to get rid of everything here in moment 2. I could certainly code that, or I could just select it and throw it away, right? So I just want to emphasize that designing a user interface and offering pictures to look at and click on is never about dumbing something down. It's about making tasks easier and more efficient for us human beings who require that. And there it is. Let's see. Now, I debated whether or not I should try to cram a crash course in quantum concepts into a 20-minute talk, but I think it would take me about an hour to comfortably walk you through this stuff, and it gets a little mathy. So I'm going to mostly spare you, except for this. I want to give you a small taste of what's going on here, and hopefully that's intriguing enough that you will visit the QJS site on your own to learn more. And better yet, check out our list of links and references so you can jump straight into some good source materials on your own. So here we go. This is an actual page from the QJS website describing qubits and what they are. And it starts out by saying qubits are just a pair of numbers. So a quantum bit, the smallest unit that you will use to do quantum computing, can be represented by a pair of numbers. Now, you might physically represent your qubits using, photons or something else, but mathematically, it's just two numbers, that's it. And we can name one alpha and we can name the other one beta. And the thing that makes this pair of numbers special is their relationship to each other. And here it is. Alpha squared plus beta squared must always equal exactly 1. And the reason is because alpha and beta represent the probabilities of a bit being 0 or 1, on or off. And the sum of those probabilities must always be 100%, right? In the end, there is an outcome. And And here we can just scroll down. You can see there's a whole lot more information here, descriptions of why qubits are named certain things, in-depth descriptions of why some are on and some are considered off, ket notation, all sorts of things that I'm just glossing over here, but you can really spend your own time with and get to know. And this is my favorite right here, is the block sphere representation of a qubit. So we can see this horizontal qubit, which is considered 0 or off, and the vertical qubit, which is its inverse. So this is considered on. And we also have all these other states. We can just kind of rock around the clock here and see different qubit states. And qubits are really just matrices and vectors. And this will make a lot more sense in context when you look at gates and circuits. One thing I just wanted to mention really quickly before we jump out of this is superposition. So you've probably heard some things like superposition means two things happen at the exact same time, or maybe neither happen, or something like that. Superposition just means a state where the probability of outcomes are not 100% yes or no. It's some mixture. That's it. I really like to demystify superposition because there's a lot of kind of pop science nonsense around it that just really doesn't translate once you learn the math. One more thing that I want to touch on here is there are some purposeful quirks to this library. For example, when using the verbose syntax to do things with qubits, you'll notice that some commands have a $sign, for instance, at the end. This is a warning sign from the API. If you use the $sign, you are mutating your state. You are overwriting the value of that variable. And you can see an example here where you add cat and dog, and it's destructive, right? Notice that $sign suffix, as opposed to the non-destructive version, which will not change the value of cat. So that's just one example of some of the fun things you might encounter as you explore. And oh, right. I said I'd touch on quantum hardware again, and here it is. I happened to work at Amazon for a little while in their web services division, and Amazon just so happened to be working on a quantum service called Amazon Bracket. You can access Bracket through a prepared Jupyter notebook. Perhaps some of you might be familiar with Jupyter from doing machine learning. Anyway, here's a little demo video I made a few months before Bracket launched, using the QJS interface to drive it. So here I have a Jupyter notebook with Amazon Bracket loaded, which means that I can use Python code. Bracket is a Python library, and I can use that to build quantum circuits that I can then run on a simulator in the cloud, or I can run on quantum hardware, because Amazon has partnered with different quantum hardware vendors. And so we can do that. We can offer that to our customers, and that's pretty exciting. But what's also exciting is this. With just a few lines of HTML, really 2 lines of HTML, I can inject QJS into this Jupyter notebook. It's now injected, and now I can inject my quantum circuit composer. And this composer, which should look awfully familiar, is writing Bracket code. So this is actually Bracket Python code, which right now is set to run on the simulator in the cloud so that we can get quicker results. But if you wanted to, you could switch what device we're running on, and you could actually run this on quantum hardware and get true quantum results. So check this out. Down here, you can see where it says our QJS circuit equals a new circuit, and it has a placeholder identity gate. This is Bracket code, and we're about to watch it change as I start to compose stuff. Look at that. Look how it put a Hadamard gate and created a C0 gate And we can take that and we can run that. What this is a coin flip circuit. And we're waiting for the output to come back from the cloud. So Hadamard puts the qubit into a state of superposition, and then this distributes that superposition to the qubit on the second register here. And so our two possible outcomes are 0, 0, and 1, 1. And you can see we've gotten a result back from the simulator. It's run that simulation 100 times, which is a customizable number. And it's come back roughly even. 54 times it came out 0, 0, and 46 times it came out 1, 1. So here's the deal. We can drag and drop and build circuits as we please using the QJS drag and drop interface. We can even edit that thing and get real-time reports in the JavaScript console still. And it is building Amazon bracket code, which we can run on a simulator or on actual quantum hardware. So that is pretty cool. It is pretty cool. That right there is proof that you can use QJS to drive actual quantum hardware. And to me, that's really special. All right, let's wrap it up. So folks, this is where I can use your help. QJS is open source. It's on GitHub. Do you like JavaScript? Do you like quantum computing? You can jump right in. And there are open issues that you can check out. Ongoing discussion that could use your voice. There's a lot of documentation, and it's easy to get started, I swear. And hey, if I've said anything insightful or smart about quantum computing, it's just because I'm channeling these folks right here. So look them up. They have videos, books, courses, and so on. And as always, MIT OpenCourseWare and Stanford Video Lectures are great free resources. I'm Stuart Smith. This has been Quantum JavaScript. You can try it out right now in your favorite web browser. Just go to quantumjavascript.app. From there, you'll find everything, including the GitHub repo. Please do get involved in this project. I want to make quantum computing accessible to everyone. That's worth saying again. I want to make quantum computing accessible to everyone. So let's do it.
Thank you so much for that intriguing session. I hope everybody is joining the spatial chat to talk some more. A little word from our gold sponsor, Docker. Millions of developers, use Docker to build, share, and run applications with an integrated, reliable, and secure workflow that accelerates app delivery from code to the cloud. See how at docker.com. And for our next speaker, Andy has over 15 years of experience with web development, has grown his skills with the web platform along the way. Join the talk and find out how Andy's company handles dependency resolutions when building native web component-based applications that rely on packages published by many different teams. Go to the community track, leave your applause there, leave your questions there as well, comments, compliments, everything. And Andy, please get us started.
How's it going, JS Nation? Today we're going to talk about immutable web apps and dependencies. First, I'm Andy Damaris. You can find me on pretty much all the social medias at Teradox, and my website is teradox.tech. So what we're going to cover today is we're going to start with the problem. There was a problem that we were having at Meltwater, and then we'll move on to immutable web apps, what they are and why we're using them, dependencies without bundling them, referencing those dependencies, and then last we're going to talk about how we order those dependencies successfully. So what's the problem? Well, the problem was dependencies. We had a lot of them, and they were being created by internal teams for libraries that we could use on a regular basis for things like authentication or companies lookups or users lookups. And each of these things was beginning to compound the amount of duplicated JavaScript that was being bundled together with all of the different applications we were shipping. So we needed to figure out a way to unbundle these dependencies and allow them to be shared more effectively between the many applications that were using them. So immutable web apps were an important part of that journey. So we're going to cover those first. The basic philosophy of immutable web apps is that you want to build them once and deploy them many times. There are some really specific fundamentals that we need to accomplish in order to be an immutable web application. The first one is all of our environment variables need to be outside of the bundle. This allows our bundles to be built one time per version and be immutable for that specific version. They'll never change after the first time they're built. It also means that we need to deploy them to a URL where the version that we just built is included as a part of that URL. So we want that fully qualified URL to have our version number in it somewhere. Now, what benefits does this really buy us? There's a bunch. The first is that when we're testing in staging and we're testing in production, they're using the exact same assets. The only difference will be the configuration that's changed between the two. This means that all of our assets can also be maximally cached. They can be cached for a full year, in fact, which is the current browser maximum. There's a huge benefit to our customers for that. They only ever need to round trip for that specific version of that specific asset once. And after that, it's on their local disk cache, saving huge amounts of time for secondary and tertiary loads of the site. We never have to worry about them having to go back to origin constantly for these large assets at times. The other things that get included with this are you always know which versions are deployed because your index.html page makes it very plain. Look at your script tag. What version's in the URL? That's the version you're dealing with. It also means that rollbacks are now really trivial. We're just flipping back from one specific version of a set of assets to another specific version of a set of assets. And if you're a consumer already, chances are good you already have that previous version of assets in your disk cache, ready to go. So you won't even have to pay download costs again for it. So we've talked about all of our assets, but what about the index page? Well, the index page is the one part of an immutable web app that you don't cache. It's our focal point for where all of our changes are allowed to show up immediately. So we like to break things down into 3 different thought processes. You don't have to break it down this way. It's just an exercise in a way to think of things. So the first piece is just our static web hosting, right? It hosts our index.html page. That index.html page is pretty static. There's not a whole lot of dynamic nature to it. And it dictates the versions of all of the static assets that we're going to deliver. Those static assets are then delivered using script tags, and those script tags use the fully versioned URL that we were talking about, in this case, version 1.2.3, to be able to deliver those assets. Then we also have our APIs, and our APIs could be on a different server, could be on the same server, but we dictate which API we're going to hit by that configuration block you're seeing in the script tag. That configuration block tells our application where we should go to hit that API and what the route should be, removing that environment variable from our JavaScript code. So I've glossed over immutable web apps pretty quickly here. There's some more nuance, a lot more detail that you could dig into. And if that's something that's interesting to you, please check out immutableWebApps.org. So now let's dig back into the main crux of what we're talking about, which is dependencies. We have a lot of them. They're being used by a lot of different applications. So how do we fix that problem? Well, we're going to need some tooling to do this successfully. The first little bit of tooling we're going to use is UMDs. They're a specific type of bundle that we'll dig into. And then we're going to talk about Hi My Name Is, a tool for helping us discover dependency names. And then we'll talk about Orchard, which is really our tool for ordering those dependencies. So the first tool I want to discuss is UMDs, the Universal Module Definition style of bundling. Pretty much every bundler out there supports it, and it allows those bundlers to give a specific name to a package of code that will then end up on the global disk scope in the browser. The benefit of this is that now we can reference that module using the global this namespace that it's occupying in order to bring it in without having to bundle that dependency into our other code. The example that we're going to work with today is meltwater visualizations. And you'll notice that when we're talking about making a name for this UMD bundle, we include that suffix of a V major version. In this case, major version 14 of meltwater visualizations. The reason for this is that when we reference a major version, it allows us to potentially load multiple major versions of the same dependency in the page at the same time. Now, you might be thinking that that feels like a bad idea, and I agree with you. But there's also benefits to being able to do that. When you have a lot of intertwined dependencies, not all of them are going to be able to move at the same pace. Upgrading a dependency for like visualizations to version 14 when other people are relying on version 13 might mean that everyone has to upgrade at the exact same time and do a very large forklift upgrade. But if you can load Meltwater Visualizations 13 and Meltwater Visualizations 14 at the same time, you give those other teams an opportunity to upgrade at their own pace, at a reasonable pace that makes sense for the workload that they're under. And that means that versions can move more slowly. And instead of having to do a forklift upgrade, you can now upgrade versions when they make sense to do so for your team's movement. Now, this doesn't mean you shouldn't be mindful of a lot of duplication of code. That's how we ended up here in the first place. But it does mean that it makes that upgrade path a lot smoother across a lot of different teams. So how do we use UMDs within our bundle? Referencing them comes down to bundling tools. We'll start with Webpack. Webpack has a property called externals. Externals allow us to load those UMDs that have been put on the global this scope by referencing them using their module name. By using their module name, it tells Webpack, I don't want to bundle this node module anymore. Instead, I want to make a reference to that node module to this corresponding global this namespace. So a couple of things are happening here. One, Webpack is being told to ignore bundling that module name. And two, that module name is being set up to correspond to a global this namespace object that should exist. The benefit of doing it this way is that when we're testing with something like Jest or Vite test, we can still use that node module to be able to run our tests. It doesn't have to reference the browser-specific code if we don't want it to. This means that our testing and mocking is much more straightforward than if we were always relying on the global this namespace. The benefit there is easier test setups, easier to debug, and your local code runs the way that you would expect to. It's wonderful to know that we can just use the npm module for local testing and know that that will act the same as when we're deployed. Now let's look at what a rollup config could look like for this. In rollup, those two things we were talking about that Webpack handles in the externals get divided out into two separate configuration options. The first one being which modules are not going to be bundled together with us. That's what the external property is for in rollup. It says, here are the modules I just don't want you to load. You don't need to bundle those into my bundle. And then we can, down in the output globals option, use that same type of map we saw in Webpack, where we reference the left-hand side as the module name and the right-hand side is the global this namespace that we want to resolve for that module name while we're bundling. It has a very similar output in the way that we are referencing these things, and it makes it very straightforward to reference UMDs from the window object. But if we start thinking about when we get to 20 or 30 or 50 of these dependencies, maintaining that config is exhausting. There's so much to maintain. Every single one of them has a major version we have to keep track of. When we upgrade our package JSON, that major version could change, and then we have to remember to update it in the config. I mean, it gets to be a bit of a mess. But luckily, we can automate that. And we can automate it through a package called Hi My Name Is. This package is going to be open sourced, hopefully within the next month, and you'll be able to take advantage of it. Hi My Name Is basically a library that allows us to build out that module to namespace mapping that we were talking about without you having to maintain that yourself. And it does it with two very straightforward functions. The first function is called generate namespace from package. Generate namespace from package allows you to build that global this namespace we were talking about, including our major version, so that we can populate it into a new package JSON property. That package JSON property is called browser namespace. This property gives us the ability to resolve that information later in the build. So once you've got a library that's using this and building out that property in package JSON, it means your consumers are now set up to be able to successfully reference them. Let's look at what that looks like. The second function out of Hi My Name is get package namespace mapping. This function goes to your package JSON for your project and looks at all of the dependencies. It ignores the dev dependencies and resolves those dependencies to look at their package JSONs. If the package JSON for that dependency has a browser namespace property in it, it uses that to build out the mapping of module name to global this namespace. So you don't have to maintain that anymore. As you're versioning, it'll just get versioned for you. Every time you build, this will resolve appropriately in a very rapid manner and give you that mapping that you need. So in Rollup, it's a little bit more complicated, but not much. Similar to with Webpack, the get package namespace mapping function still gives you that globals object, but then you also need to build out that external array like we referenced earlier. Luckily, the get package namespace mapping has all the information you need to be able to do that successfully. Okay, but we still haven't tackled ordering, right? And that's a much harder problem because dependencies can have dependencies, and they all need to be loaded in the right order in order for this global this resolution to work appropriately. But we can automate that too. That's where the Orchard CLI tool comes in. It, very similarly to Hi My Name reads your package JSON, looks only at your dependencies, ignores dev dependencies, but instead of stopping at the shallow level this time, it uses a package directly out of npm.js called Arborist to build out the full dependency tree. Arborist is basically behind the dependency tree resolution for things like npm install. It allows npm install to build out that full dependency tree to understand what new packages need to be put where in that dependency tree. It helps build out the package lock JSON as well. So very powerful tool that we did not build in order to make this system function. Using that dependency tree, it then builds out a set of script tags based on that dependency tree resolution, and then we limit that using a curated set of YAML files. Why a curated list of dependencies? Well, there's a couple of reasons. The first one mostly is safety. We don't want just any package being loaded from Node or loaded from NPM. We really want to limit it to just things that actually we want to be loaded into the browser. By limiting that, we're kind of limiting the number of things that can load to a very specific subset that we actually care about. It also helps by limiting that dependency tree resolution to a much shorter amount of time by trimming branches that are no longer relevant. So with these tools in place, we have this YAML file now that we need to worry about with the Orchard. Luckily, it's a reasonably straightforward YAML file. Here's what one looks like for an internal dependency. At the top, we have ownership information. It's wonderful within a large organization to be able to know exactly who is responsible for the dependency that you're relying on in production. That's a part of what the Orchard allows us to keep track of. Each of these YAML files has an owned by, a repo, and a contact property that allows us to keep really close track of who is actually in control of these different dependencies. Then under the technical details, this is where we're actually building out the path for each of the dependencies that we're loading, either via script tag or a link tag. We've split it into these three parts for a really specific reason. We wanted a suffix that kind of is the base path that these things will be loaded from. And then we wanted a version path that allows that version path to be maybe prefixed with a V or an @ symbol, depending on where it's being loaded from. And then the suffix is the specific files that need to be loaded. So in the case of what we're looking at, this would load a script tag with type equal module, and then resolve out that base path plus the version plus the ESM path as the source for that script tag. It would also create a link tag based on that, once again, that base path, the version, and the CSS path to build out that link tag, allowing us to create a set of ordered dependencies. There are two other properties in here that are worth calling out. One is conflicts with other major versions, which is that call out before of the fact that we try to make sure that our internal libraries can run with multiple major versions at the same time. And this would be the spot that we would kill a build if two different versions of the same library were trying to be loaded that cannot interoperate successfully. And the last one here is requires initialization. There are some internal libraries that require you to run some initialization code in order for you to be in an appropriate state. And we like to call that out for our consumers so that they know exactly what they need to bootstrap. Looking at an example for an external dependency looks very, very similar to an internal dependency. In this case, Moment.js. We can see that the ownership stuff has shifted a little bit. It's no longer an internal concern, so we don't have things like team name, but we do have things like the repo that it came from and where I can go to contact them if I need to in case of an issue. The technical details are also very similar. In this case, you can see that we're using ES5 instead of ESM because there isn't an ESM version of Moment.js. So all that means is that instead of being a type equal module script tag, we'll now get a script tag with a defer on it, which basically allows that script tag to be deferred until after all of the HTML has been parsed, and it will follow the same ordering process as a type equal module for when we're doing that resolution. You'll see here that we have conflicts with other major versions set to true. You can't load multiple major versions of Moment. It's just not allowed. They occupy the same global this namespace and would overwrite one another. So that's a couple of examples of YAML files that are used to configure the orchard. I want to take a second to talk about some of the outcomes of doing this work, the benefits that it's provided us at Meltwater. And the big deal here is it's a good thing. It's really helped us cut down on the customer issues that we were experiencing. By having staging and production be relying on the exact same versions of the code, we no longer worry about logic changes that could sneak in between staging and production. We also have decreased our bundle sizes overall for our application bundles by making those dependencies external. Those dependencies can then be relied upon by many different applications across our application suite since they're all loaded at the same domain. We've also seen that caches are getting hit much more often. We're seeing a lot fewer requests for upstream files since they can be cached so heavily on the browser. It's really helped a lot with user load times. So a quick summary of everything we've talked about today is we had a problem with a lot of libraries being loaded in a lot of different applications and that duplication of JavaScript being downloaded. So we took an immutable web apps approach to making sure that all of our assets were versioned fully and maximally cached. We build them using UMDs, which allows that global this namespace to be created. And it can also be loaded via the bundlers that we're already using. And then the little bit of tooling for DevX is hi, my name is, to allow those dependencies to be resolved more quickly and more easily. And also the orchard. The orchard is responsible for loading those things in the specific order. So I covered a lot during this talk, and I know there were a lot of topics here. So thank you for your time. Thank you for listening. And if you have any questions on any of these topics, definitely reach out to me on social media. I'll do my best to respond as quickly as I can and answer any questions you have. Thanks so much again for your time. It was great being here to speak.
Thank you for that talk. I hope that a lot of people are joining the spatial chat right now to talk some more. And also, please remember to tweet about the talks that you like most, maybe like your best experience so far or what kind of snacks you're having. Word from our gold sponsor, Decentrology. Decentrology makes Web3 accessible to millions of web developers by making it easy for them to discover, build, and monetize the apps. They're the innovative company behind Hyperverse, the open and on-chain code marketplace. On to our next speaker, Ryan. Ryan is obsessively passionate, his words, not mine, about the future of JavaScript frameworks. He's the creator of Solid.js and the maintainer of Marco. His talk will reflect on the challenges of modern web development that motivated Solid's creation. By retracing his steps from the simple beginnings to a fully fledged framework, Ryan will showcase how reactive primitives are the only building blocks you really need. So please go to the community track, leave your applause, leave your questions, and Ryan will be sure to answer those. Ryan, the stage is yours.
Hi, I'm Ryan Carniato, author of Solid.js, and today I'm going to present an introduction to it. What is Solid? Well, it's a declarative JavaScript library for building user interfaces, like so many that have come before it. Solid, on the surface at least, is a very React-like framework. It values the same things: unidirectional flow, read-write segregation, and immutable interfaces. It's built on the same building blocks, hook-like primitives, function components, and JSX. And it has a lot of similar features, things like portals and fragments, suspense and transitions, streaming SSR, and some others too that aren't in React, like custom directives and primitives for data fetching. But, and there is a but, a rather large one, Solid is sort of nothing like React. Solid is built entirely on fine-grained reactivity, similar to MobX and Vue. Its components only render once, and there's no virtual DOM. The whole mental model is completely different. Same values, entirely different implementation. But what does that actually mean? Well, modern front-end web development for years has been about components. Class components, function components, option components, web components. And for good reason. Components are essential building blocks that allow our programs to be modular and composable. However, in almost every JavaScript framework, they have runtime implications. The update model and the lifecycles are tied to them. And this has led to basically two views of the world. Either you use a top-down diff like a virtual DOM or tag template literal, or alternatively, you rely heavily on compilation to separate creation from update. But both of these still have components that basically run top-down. And this kind of begs the question, when and what to memoize? This is important for performance because if you're going to call something over and over again, you don't want to repeat the work. There's a great talk from Sean at ReactConf 2021 that addresses this exact thing. Your first inkling might be to build your to-do app in a framework like React, kind of like this. Declare some state, and wire it up. But on any change, even unrelated to the to-do list, you'd be re-rendering the whole list. But maybe that's okay. That's why there's a virtual DOM, to make sure this isn't as expensive. But maybe you still want to optimize. As your program grows, you apply your optimizations, and things may start looking like this. Maybe you add a filter and some theming, and there's nothing innately wrong with this. But now we are annotating things with memo and use callback, and adding our dependency arrays and ensuring that everything runs exactly how we want it to. But it's a bit of a departure from where we started. So let's compile it. And this might be what you'd end up with. To be fair, this is not the code you'd write. This is compiled output, kind of pseudocode from an experimental compiler that React team is working on. But it isn't actually all that different from what a framework like Svelte would be doing. It's a bunch of shallow referential equality checks that at every decision point rerun when your component is marked as needing an update. Common ground is a component updates state, then runs an update function and checks against these memoized values, as shown here in this mem cache. But what if we didn't? What if we only ran what was needed to be run and didn't rely heavily on compilation? What if the boundaries of our components didn't dictate the performance of our web applications? To do that, we need to kind of go back to the beginning. And I'm going to go all the way back to the beginning. Remember the first program you wrote. Maybe it was a hello world. You were able to set some data in a variable and log it on the console. And it didn't take too long before you realized, well, you could set a new value to that variable and log it again. This is the beginning of programming. But then you realize, well, that's a lot of repetition. So let's extract that out into a function, maybe a greet function here, and we can have a set our name and then call greet, and then set our name and call greet again. And this is all great, but at a certain point, maybe you're like, every time I set the name, I want it to greet without having to call it. And that's where reactivity comes in. Reactivity is based on primitives. It's kind of like a promise in JavaScript. In our case, we're going to introduce the first primitive here, and it's called a signal. Signals are relatively simple. They are just a wrapper over a value. They have a get function name here and a setter, which set name. And in this case, we have to replace this assignment we have here now with set name so we can update it. And we need to replace our name. We need to call it now because it's a function. And once we've done that, it basically acts the same. We can still see hello world and hello solid.js. That in itself, to be fair, is not terribly interesting. So we have another primitive we're going to introduce here called create effect. And what effects are is they allow us to interact with our world whenever a signal changes. In this case, we're going to take our console log and we are going to put in the effect and have it listen to name. This lets us clean up the rest of this code, essentially. So now we just create our signal for the name and then create the effect. It runs once. And then when we set the name again, it runs again. And it does this because we call name as a function, which lets us intercept reading that value. And this can actually extend outside of the effect itself because this is not a compiler trick. This is completely runtime. So we can make a uppercase, and now we can basically call our name in here and change it to uppercase, stick it in our effect. And because it's just using the runtime stack, we can see hello world and hello solid.js now in capitals. So you might be wondering how this works. And it all comes down to this idea of fine-grained reactivity. Creating a fine-grained reactive library can be done in about 50 lines of code. I'm going to simplify it even further here for demonstration purposes. But it all starts with signals like we saw. And at its core, you just view a signal as a getter and setter function pair that close over a value. Of course, there's a little bit more to it than that. And for that, we're going to need subscriptions. So let's update our signals to do a bit more. Now on read, what we want to do is check if there's a current observer. And if there is, we're going to add it to a new subscriber set that we create when we create our signal. On write, we update our values still, but now we actually iterate over those subscribers and call them to basically notify them that something has changed. And that something that needs to be notified are our effects, which are the other side of our equation. Here you can see the implementation for get current observer. What we have is a stack. This context is just an array, global context, and we just grab whatever's at the top of the array to see what's currently running. For our effect itself, when it's created, it's executed immediately, and then it goes through this cycle of clean up dependencies or subscriptions, push itself onto that stack, so that when we execute the provided function, it's there and can be added to the subscriptions. And finally, it pops itself off the stack. I'm going to put the code side by side so you can kind of see this better as we go over our example. Essentially, we create our signal, like our name signal, and it returns our read and write functions. Then we create our effect. It executes, pushing itself onto that stack. Then it runs that function, and it reads from our name signal, at which point it sees the current observer, which is that effect, and it adds it to its subscribers. Then it logs it to the console, and the effect finishes running, popping itself off the stack. Sometime later, our signal is updated, which sets a new value, and then executes our list of subscribers. In this case, it's that effect, which executes it again, cleaning up the dependencies, and we just start the whole cycle all over again. And that's really it. From there, we can build a foundation for other primitives. A lot of them are not essential, but can be used as needed. But an example of a few important ones that ship with Solid are create memo, which can be used to cache expensive computations, create store, which is a proxy, which enables deep nested reactivity, and create resource, which is our first party primitive for data fetching and suspense. But enough on reactivity for now. Let's get back to our example. when we teach reactivity, we always use like console logs, but let's do something a little more substantial here. Let's actually create a DOM element this time and see what it does. So what we're going to do here is we're going to create a header, and we're going to set some text on it, and then we're going to attach it to the DOM. Okay. And then we're going to take setting that text on it and put it in the effects. So now whenever the name changes, it will update the DOM. And in this case, we set the solid.js right away, so you don't even see it. We just see hello solid.js because it updated right away. So to deal with that, let's create a button, and we'll put the setter inside a click handler. So we're just using vanilla DOM APIs here so that we can make it work. And there we go. Now our hello world has a greet button, and when we click greet, it changes it to hello solid.js. But I mean, this is a lot of code. Who wants to write all that vanilla JS? Wouldn't it be great if we could just write something like JSX? And in Solid, you can, because JSX in Solid is just DOM elements. So this is a real HTML button element we're creating here, and we're just going to put a click handler on it, clean up that code, and our example still works. And we can give the header the same treatment. The one difference here, though, is that the header has a reactive statement, and Solid's compiler can actually see that we're calling a function in the expression, so it knows to wrap it automatically in effect. And when we do that, sure enough, it still works, and it's a little bit cleaner here. But we don't really write our apps this way, so let's abstract this into a function, or a component, so to speak. But this is just a function. We can clean this up a little bit and maybe return the elements as an array. And then we can just call our function and just attach it. And as you can see, it clearly still works. But let's inline the JSX a little bit more, clean up a bit more, remove all of that, and then format it with prettier. And here we go. Okay, we can actually replace the array with a fragment, because that's all fragments are in Solid. And this is starting to look pretty good. Last thing we really have to deal with now is just how we're attaching to the DOM. So Solid provides a render function, and we can just render our greet component, and there we are. This looks like any modern framework. But there is one big difference here. Solid's components only run once, because as you saw, we're just calling this function. So if I put a console log in here, like greet, let's say greet, and you'll see it logged. When I press it, it's not logging again. It only logs once, okay? So let's do that one more time, okay? Here we are, hello world, see the greet, press it, yeah, only once. And yeah, let's extend this a bit further. Let's actually use two greet components now. We're gonna put this inside an app component that we use. And by doing this, you can see that each component can wrap over its own state. So now we have two of them. We can see that it logs the console greet twice now, but when we update each one, it doesn't log again, and they update independently, each maintaining their own state because they have their own signal. But we can actually take this signal and pull it right out of the component above. And now it's shared because both instances of the component are reading from the same variable, like it works in JavaScript. And sure enough, it doesn't matter which button you press, they update the same state, and the console logs only log on creation, not an update. But most of the time you're going to put this in props. So let's put this into app and pass it down as props. So we can also move the click handler up and pass it through as well. And this is kind of how composition works in Solid. The important thing to understand here, though, is only where that header text is it what actually gets updated. We are sharing the state passed here, but the components all only run once. See, this app console log will show that even when we update it, it's not going to log it again. And actually, to make that more clear, I'm going to take this set name and I'm going to actually have it increment differently for each component, even though it's using the shared state. Even though we're kind of passing everything through, when we actually do an action, there's only two effects on this whole page, and those are for both headers to update that text. Okay, so what's going on here? Well, it's because of the way we handle component props. In Solid, the only thing we actually transform is the JSX. And for components, when we see an expression that contains JSX or something that could be reactive, like a function call, we wrap it in a getter, like this get name. And what this does is allow it to be evaluated lazily. It's very similar to what we do with DOM elements, where if we see something that could be reactive, we wrap it in an effect. Basically, everything is lazy evaluated all the way to the final effect, which actually does the work. And as I said, there's only 2 effects in that demo. The only work being done is updating that single text node inside each header. Nothing else re-executes. The last thing you probably need to know about solid rendering is that we're dealing with real DOM nodes, and creation can be wasteful. So we need to do some special handling for things like lists. A simple array.map would never run over, would run over every item and map new results. And we don't want to create all new DOM nodes every time we add something to a list or sort it. So we need to do something a little special here. For solid, we have helper functions, but we chose to ship them in the form of components, as they fit well with our patterns, and they are very composable, like the rest of the primitives in our system. What do I mean by composable? Well, pretend now we need to update this. We only want to show 10 items on each page. We need to paginate. Luckily, someone has created this component for that. So what do we do? Well, maybe we import it, and now we just change our for component. And as you can see, it's exactly the same pattern. Lists become paginated or virtualized lists. Conditionals become layouts or suspense or error boundaries. It's all the same thing. If you don't like Solid's for component, it's just a component. It's runtime. You can write your own. This is really powerful stuff. And armed with this, we can kind of return all the way back to the beginning with our to-do example. So I've recreated that example in Solid that we saw at the beginning. And we have a to-do list, and we have a handler that we have set up our state of our to-dos, and we have a handler that will update our to-dos to done. And what we've done here is we're actually passing in a visibility filter and a color picker. And this gets passed all the way through to our add to-dos to kind of set the theming. So this adds a little bit more, complexity, or you'd think. But in Solid's case, without the need for adding any memos or use callback or dependency arrays or basically anything additional, we can just take our list, filter it based on that prop, and only have the things that need to update. For example, when we click this 3, yes, now we're going to update it to do, and when we unclick it, we update it. When we change the filter, it gets called. But as you can see, updating the to-do did not cause the filter to get called. And if we go back, well, we're going to have to recreate those 3 elements. So yes, we called the filter again, and we updated 3 times. But this prop getting passed through here for the theme color, us changing this doesn't cause the to-dos to update or the filter to update. It just works. And we did this all without any kind of memo. Actually, the hardest part about making this example was trying to show what updated, because so little does. This is what happens when you have fine-grained rendering and updates. For me, I call this the reactive advantage. Basically, components run once. There's no hook rules or stale closures, or dependency arrays for that matter. Templates compile to real DOM nodes. This is super low abstraction over the DOM. It means that you have that escape hatch. You need to do something with the DOM, it's right there. But most importantly, state is independent of components. Component boundaries are for your sake, how you want to organize your code. It's not about performance. The performance is good regardless. So, if you want to experience the freedom yourself, maybe give Solid a try. Thank you.
Thank you for a great talk. I hope everybody's joining the spatial chat to talk some more. Our gold sponsor, StackHawk, makes it easy to automate application and API security testing in your CI/CD pipeline. Find and fix security bugs before they hit production with stackhawk.com. On to our next speaker, Carolina. Carolina is always exploring new paths and looking for a new perspective to solve problems. As a computer scientist, she loves to work in challenging industries. Who doesn't? In this talk, we'll explore how functional programming, tests, and hexagonal architecture can perform great together in order to support maintainable code base for hundreds of engineers and services. Join us in the community track channel on Discord and leave your comments, questions, and everything. And Carolina will surely join and answer all of those questions. Carolina, whenever you're ready.
Hi, folks. Today I'm here to talk about how you can build a sustainable architecture. First, I'm going to present myself. My name is Carolina Pascali Campos. I'm from Brazil. I'm a software engineer that works at Brisa. And here you can follow me on my social networks. And I love books, coffee, and running. So let's go to the presentation now. So the main topics that I'm going to talk about today are functional programming, tests, and hexagonal architecture. So let's start with functional programming. We know that functional programming is about pure functions, right? So given its inputs, we are always going to return the same output, and we're not going to have side effects. So when we talk about side effects, it could be like saving to a database, sending an email. So anything like that. But it's important to have in mind that we will also need to deal with improved functions, because we know that in order to have like a useful code base, we need to have improved functions. Our programs need to have input and output. We want to be able to interact with it. And those interactions always happen in improved functions. So after we write to a database, for example, we're going to change its state. So when we are going to read from that database after saving to it, the results going to be different, and how we're going to handle that. So we need to talk about side effects. When we are like functional programming, we love to talk about the pure things, but we also need to talk about the effects. And that's a really important topic to be discussed, how to deal with them. So we need to be really careful about the improved functions because they change state. So if I run something today, tomorrow the results can be different. So this is the hard part to manage, but we need to manage that. So that's the reason we need to carefully structure our database to not mess with it. So here's an example. Imagine that you have an improved function inside a pure run. So you no longer have a pure function. This is why we need to be careful about structuring our code. We want to maximize the pure functions we have. So we cannot call an improved function inside a pure run because we have just lost it. So we need to separate what we built. We need the effects from the pure functions. The effects can infect everything. And our goal here is to maximize our functional programming and to minimize and isolate the improved functions, the imperative code. So what we need to have in mind always is that if a function could be pure and it's not, we are doing it wrong. So let's try to refactor this. Another powerful thing about functional programming is when we talk about immutability versus mutability. So let's start with the image that we have on the left. So we have a book with many pages. This book is the identity. When you want to change something in the draw, you just turn the page and draw new thing in the end. So the act of turning pages represents the state of the draw during time. So if you stop on a page, you can observe the state in a certain point of time. But if we look now to the right, we have a mutable example where the book is only one page. If we want to make a change, we need to erase stuff and redraw things. So we have just lost the notion of time here, and state and identity are now blended. So when we talk about like immutability here, we have the animation. You know all the steps the draw has been through to get to the end. You know the whole story. So when talking about pure functions plus immutability, we are going to have functions that are easy to reason and easier to debug. This is what we want, because with pure functions, you know that given an input, the output is always the same. So it's really easy to reason about it. And also with immutability, you always have no pages and when you change something. So you don't need to go deep in the code to understand which function is mutating the page. So we want to be mindful about the things we want, that's pure functions and immutability, when developing, so we can seek them, because this combo is going to give developers a lot of power and speed. Nice. So when programming with functional language, we want to focus on data, calculations, functions, and not classes, interfaces, and boilerplate code. So the intent of our code is clear, and you can try new things faster. So what we want here is be as functional as we can to be able to move faster and with confidence. Now, let's talk a little bit about tests, because if you want a sustainable code base, we need tests. And tests are important because they give developers confidence to extend or change our code. So when trying to understand, for example, a code we didn't write, we can check the test to understand what was expected from that code when it was written. So it's also a live documentation. If we change code, we need to change the test, because otherwise it would get stale, but they don't, because it's a live documentation. But how do we know and check if our program is doing what it's expected to do? How can we check the quality of this feedback? And here I'm not going to talk about 100% coverage. So let's start with accuracy. If your tests fail, can we determine exactly which portion of the code has failed? How long do you take to know where it failed? So what we want here is functions that are really granular. So as granular as it is, the more accuracy you can get. So it's way faster if you have like small functions with no dependencies from the outside world. So let's remember pure functions. Also about speed. The faster we find a test failing, the sooner we can identify the problem and smaller the impact will be. So what we need here is tests that are simple to write and to maintain, and also that are fast to run. If we have a lot of complex code with a lot of dependencies from the outside world, it's going to take a lot for us to maintain these tests. And also, we need tests that are reliable. We need to trust the outcome of our tests. If the outcome changes from one execution to another, if we don't change the code, the configs, or the dependencies, why would we keep this kind of tests? Because we don't trust them, so it makes no sense to keep them. And here we are usually talking like about end-to-end tests. So end-to-end tests are a problem because you don't mock anything, you really save stuff to the database. It's really common for them to failure for like obscure reasons like latency, garbage collection, asynchronous operation. So we need to think in a different way. So here we need to think on a little bit larger. We know that unit tests cover the function levels, integration tests cover the flows, and we need to guarantee that conversation between services is working. So usually we use end-to-end for that, but we can just think a little bit larger and test the conversation between two services at a time, for example. So here we use contract tests. So every contract test is going to have a provider, service, the consumer service, and for each communication between them, we need to define a clear interface called a contract. So now we have like automate tests that assure the data generated by the provider can be consumed by the consumer. And if we change anything, the contract is going to break. So it's important here to have in mind, this is not a one-to-one replacement with end-to-end tests, but most of the errors that end-to-end catch, those tests can also catch them. So with that, we can have accuracy, speed, and reliability. And that's what we want. So now, I'm going to talk about how to design our code. Because, okay, we have the functional programming, we have the test, but how to design the code to leverage this? What we want is high maintainability with low tech debt, because we want applications that are easy to give maintenance and have low tech debt. We need them to be simple and easy to work on. And this is hard because maintainability is a long-term concept. Because in the beginning, it's really easy. Your project has just started with a few lines of code, 3 people working on it. So it's just a couple of dependencies. But as soon as your team and your code grows, things get harder, and a bug can result in a whole architecture refactor. So that's the reason you need to think about maintainability since the beginning. What we are going to first say here, so the first attempt we had was try to use hexagon architecture. So here we have just simple hexagon architecture, the domain model, where we have the implementation of our domain. So here we're going to have the pure functions and the immutable data. That's why it's green. After that, we have like the second layer, that's where we have the controller that's responsible for connecting the ports with the adapters and the logic, the domain. So here it's all about coordination. But here we already have some functions that are impure, right? And some mutable data. So it's not all of them, but some. This is why it's yellow. And in the third layer, here is where we have, it's called the I/O or ports, and here we interact with the external world. So here we're going to have call for other services, we're going to have calls to the database, to third-party APIs. So here it's okay to have impure function and data mutation. We expect that in the I/O layer. So what we want with hexagon architecture is to be able to separate the business logic from the I/O. So we want to structure the code in a way that we protect the domain from the technical stuff. So we can define what are the business rules, what are the application rules, and what's the infra code. And how do we test in this architecture? So we want to test in isolation with mock and stubs because we don't want to rely on external database or external APIs. We really want to mock and stub things. For that, we use dependency injection, right? So the dependencies here are going to be passed as arguments. So when we run in production, we use the real database, and for tests, for example, we can use a hard-coded file. But what was the first discovery with this architecture? So remember that in hexagon architecture, we have our impure functions in the boundaries, right? In the I/O layer, the ones that generate side effects. So the HTTP requests, the emails, the messages, everything's there. So it's nice to realize that in this architecture, we can isolate and control the side effects in this layer. So we have the boundaries here, as we can see. So let's talk about this concept. What does isolation mean? So isolation is when all the info a function has from the outside world is passed through arguments. So we can come to the conclusion that every pure function is isolated. So a pure function is a subset of isolated functions. Not all isolated functions are pure, but all the pure ones are isolated. And isolation is the dual of encapsulation. So encapsulation means that the object has a state and the outside world knows nothing about it unless it made explicitly available to it through getters and setters. So isolation means a function knows nothing about the external world unless it's inputted on it. So it's the dual, right? And isolated functions are really easy to test and given for free when using functional programming. But in object-oriented programming, there are problems because of the encapsulation principle. So when developing with object-oriented code that's going to be tested, we need to find intersection between isolation and encapsulation. And that's really hard because it's way easier to work in a subset than an intersection, right? So it's hard to maintain the balance between isolation and encapsulation when dealing with object-oriented programming. But with functional programming, it's no problem at all. The minimum expected from a good functional design is to have pure functions, and they are subsetted of isolated ones. So if you're doing pure, you are doing it isolated, and you get the easiness of the test for free. And we want to have as many pure functions as we can to get all of those benefits, because we know that if you have pure function that cause an impure one, it would be impure also. So why hexagonal architecture in FP is natural? So one of the languages that help to understand that's Haskell, because Haskell is a functional language that expects all functions to be pure. And so when we are encoding Haskell, the compiler helps you if that function, checking if that function is pure or not. Because if you wrote an impure function and forgot to declare its type as I/O, it's going to throw an error. So in order to have as many pure functions as you can, you push the impure function to the boundaries. So the impure functions can call the chain of pure functions, but a pure function never can call an impure one, otherwise you get a compiler error. So we are going to have a shell of impure codes. So did this remind you of hexagon architecture? So this is why Haskell is a language that helps you discover that, because it expects all functions to be pure. And so good functional programming design can be and is Spartan adapters. And this is a great discovery. But remember that at the beginning, I said that we want to leverage functional programming to its maximum. And as I showed you, we still have controllers with imperative code and side effects. So how can why do we don't want that? Here, I'm going to show you an example. Imagine that I have this function call that's called block, and I'm passing a card, a database, and a producer. So here, when I look at this function call, I have no idea what's the output. It could be true. And if it's true, what does that mean? Okay, let's enter the function trying to understand that. So as you can see, I have the card, I'm doing some logic on it, and then I'm calling the update in the database, and after that I'm calling the producer card status changed here, right? So here I needed to enter the function to understand what's doing, and I'm not returning anything here. So I have no idea what happens before entering the function. It's also harder to compose when I have imperative code. So here, imagine I'm calling block for 10 cards. Imagine that at the third card, it failed. So now I have called the DB to update, the producer to send messages, but only for 3 cards. So I cannot just rerun stuff because I would duplicate effects. How would I handle with this composition? So it's hard because I'm just doing the things on fly, right? And what we have here is not the parameter that we want. We have a parameter that we have more integration than unit tests, because as you can see in my controller, I have those kind of functions that are calling the DB, that are calling the producer. So this is not what we want, right? Those functions are not pure, the tests are not that easy, and also the maintainability is not going to be good. So let's try another approach for that. What about if we use hexagon architecture with dependency rejection? So what does that mean? That we want to decouple the decisions from the effects. We want to decouple the intent from the execution. So the same function, but now when I call block, I only pass the card. I'm not passing the database or the producer. And as you can see, I have a return, and my return is an object that has a key called effects data, and it has its value, and a key called effects message, and it has its value. So now I know what the function does, but sure, I can enter to better understand. And as you can see, I'm just calling the logic here. That's a pure function, right? And I'm just creating, what do I want to do? What's my decision, right? And I want to update the card, and I have the data that I need for that. And also I want to send a message. I have the data that I need for that, but I'm not doing anything. This function is pure. So I can test using unit tests, for example, and it's really to reason about. Also, it's going to be easy to compose, because before we were iterating and saving things to the database and producing messages. But now I'm not doing that. I'm just creating an object. Imagine the 10 cards that's going to have an array with the 10 cards and what I want to do with them. And I'm just try to do that only in a single time, not during the process. That would be harder to recover from that. So what we have here is that now we have atomic operations, and we have data as first-class citizens, and that's really powerful. But because as you could see, we saw the data going because we are returning an object with what we want to do. Before, we were just doing stuff, and we had no idea what was happening. And when we have data as first-class citizens, we get this power to better understand what our code is doing. And also now our controllers are pure. We're only doing the side effects in the IO. That's what we wanted since the beginning, but we were not able to do with the dependency injection. So now we are only running the impure code in the IO layer, and we have the controllers pure. This is why it's also green. So that's it. We have controllers without side effects. And now we became more expressive. Our code tells us better the story of what we are doing. So what we wanted for having like a sustainable code base was to have as much pure functions as we can. We did that. It was to be able to have tests that have accuracy, because we have a lot of pure functions. We are able to have maintainability, because when we have unit tests, it's way easier to maintain the integration tests, right? And also with immutability, it's also easier to to understand stuff. It's also way easier to debug. So with this architecture, we're able to get all of those things. So that's it. Thanks for your attention. Here are, again, my social networks, and also Brisa, the company that I'm working for, is hiring. You can also follow me on Twitter, so I can tweet this link. It's going to be easier for you. But that's it, folks. Thanks for your attention.
Thank you so much for this session. And now everybody has a really difficult choice to make. Are you joining the spatial chat and chat some more with our speaker? Or are you joining the discussion room on JavaScript frameworks with Ryan Carniato, Nazar Hussain, and Brandon Roberts? Either way, we're going for a tiny little break here in the community track. So get yourself some refreshments, get yourself some snacks, and we'll see you in a little bit.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Welcome back, everyone, from your little break. A word from our gold sponsor, OLX Group, which is one of the fastest growing networks of trading platforms. The company empowers their users to buy, sell, and create prosperity in local communities. OLX Group's vision and objective is to unlock the hidden value in everything. Up next are lightning talks, which is my favorite part of any conference. The following lightning talks are up. Adam will talk about finding stealthy bots in JavaScript hide and seek. Chinyenye will talk about performance is user experience and how optimizing the front end for the users. And Alexandra will talk about how Blitz.js makes full stack web development a breeze. Speakers, the stage is yours.
Hey everyone, I'm Adam. I'm super happy to be here, and I'm here to ask what's going on with bots on the web. I'm not talking about the nice ones who do testing, I'm talking about the bad ones. So we'll talk about simple detections, how the bots got better. We'll talk about what's possibly the best bot out there cheating out most detection solutions. And we'll lastly get to my favorite part, which is how you can find it anyways. But before all that, one reason I'm here is because I always liked hacking stuff, and now I'm the reverse engineer for Double Verify. They measure ads, part of my job being playing hide and seek with these bots so advertisers can avoid them. But it's not just advertisers in the game, it's going to be social media, concert ticket sellers, a lot of people facing this issue because the internet was not designed with bot detection in mind. Seriously, the only real standard is bots.txt telling bots what they're allowed and disallowed to do. Basically, the honor system asking good people to play nice. When you do that, yeah, real story. When I was 16, high school project may or may have not dropped service to some sites. But some people actually do this on purpose and at scale, denying service to real users, using what they have to steal sneakers, sneaking around social media with fake users. I practiced that part. So to make the internet better, we want to detect them. Let's talk detections. Starting with the basics, not because bot makers can't play around these, but because they're usually the first thing you rely on when you come up with something more complicated, because simple detections are pretty straightforward. User agent. That's the HTTP request headers identifying the browser. You guys know this. You see, it's a Python bot. Okay, you block that. Probably not a real user behind that. They figured this out, the bot makers. Now they hide the user agent. Let's say you don't run JavaScript on your bot. Maybe you make a token as the detection, as the site. In Ajax, you make sure it's created. So if you have a bot that's navigating to your site, not generating this token, not running JavaScript, you know something's going wrong. But let's say they do run JavaScript. All of a sudden, you can check how the browser behaves. You people probably hate browser quirks. Bot makers hate them too because they can be used to verify what's under the hood and not what the browser is reporting at face value. And sometimes you can dig deep in JavaScript to see if somebody's trying to hide something. User agent, we talked about that. That property on the window navigator is going to be read-only. So bot markers, they're going to hide that with object.defined property. You look at the property descriptor, you see somebody did funny stuff there trying to hide a user agent. That's going to be suspicious. Image here being how you have a bad attribute identifying you. You fix it into something perfectly fine as the bot maker accidentally leave behind an artifact that can be used to incriminate you. That's going to be used for detection. This is going to be a common theme, the cat and mouse of bot detection. Another example is the bot maker can override the toString of something they're trying to hide. So you look at a toString, they hide that too. There's a fun game established there. Clever ways around this. Key takeaway being here, this cat and mouse theme that's going to repeat back to some more detections. Let's say you're really good at this dumb stuff. You make JavaScript library like Creep.js to fingerprint the browser under the hood. That only goes so far because the bot makers, they can see what you're doing. Every time you find them some way, they're going to evolve, they're going to patch a little bit, and now we got to use something else. Let's say on a site, you want to use data. That is going to be tricky because you have to mind privacy issues around real users that you're testing. But let's say you have a site that users they go to just for the sake of argument. Each page, you put a generated token, you can validate. As a user go through, you can see where that user went. All of a sudden, you have a whole new arena for catching these bots. Duplicate tokens, nonsense navigations, anything that's giving you even the tiniest hint that somebody maybe just have pre-programmed your logic in some way and is not an actual user navigating. Some of you might be thinking, hey, real users do this too, and that's absolutely right with caches and stuff. That's why this isn't a smoking gun on its own, but caches, for example, that also introduces a whole other avenue for bot detection. Some bots, they clean the cache too much, and we'll get into advanced bot and detection in just a moment, but still in the domain of old school simple detections, behavior tests. How many times should the user click in your site, let's say, in an hour? Okay, so there's going to be a little spectrum, how much each user does it, and you're going to look on the edges, and one side you have 0, there's going to be my father clicking absolutely 0 times after a long day of work. But on the other edge, you have people clicking 172 times per second. Okay, we're getting somewhere there. And also captchas, that's what we came up with originally to distinguish humans from bots. You might be asking, hey, when you start with that, reason is that the bots trained, they absolutely demolish humans and simple ones. And there's software for complex captchas too. So captchas aren't there to prevent bots. What they do currently, the reason you see them is that they slow the bots down. Moving forward, let's talk about how the bots got better. Getting closer to the advanced detection, that part, the bot makers haven't been sleeping on their guard all this time. They got better, they keep getting better. With every little patch they evolve, eventually game became rigged in their favor. 10 years ago, they're struggling with Python scripts. In recent news, it's now public, they beat Twitter. So here's some guy complaining about this to Elon Musk. Ping me in the Q&A if you want to talk about the seekers and the hiders and about this some more. I'm right about that one. Point being that the evolution thing is really good at gradual improvement and problem solving. Bots might eventually become indistinguishable from humans entirely, but moving from philosophy rambles to practice, biggest technical advancements bot made in the last 10 years, that's going to be automated browsers. Automated browsers changed the game. No more requests in Python. You're faking the whole browser. You render DOM in JavaScript. You can even fake the user. Automated browsers got really good at their thing. So that bot makers fake attributes like the user agent without leaving the artifact behind that you'd normally do in JavaScript. That makes bots more flexible, harder to detect. Browser quirks and all of that not as useful when the browser automation solutions import in the browser with whatever quirks they have. And you can fake the user too with these using vanilla JavaScript or browser hooks, say scrolling through some articles with Windows Scroll. So here's some automated browsers that are good for testing, but don't be like some of the bot operators I found out using these for fraud schemes, because they're not meant to hide anything. They're easy to detect. No, you want something better. We're getting to the kingpin here. You want something that's based on this guy, Puppeteer. That's Google's automated browser. It's not malicious at trying to hide, but it's really good at its thing and makes itself super easy to extend, makes everything super smooth. And with that, all the pieces kind of came into place. We see bots getting better, automated browsers available, and operators improving their game. Thus, the King bot was born. This guy. Puppeteer X the Stealth. Best at hiding, so good can run headless, meaning no rendering in the screen, still doesn't get detected. It's amazing, criminally easy to use, making really good botting really accessible. Community behind it is an army looking for even the slightest discrepancies. For example, they patch hardware concurrency. That's the amount of available processors you have. So they can scale the operation to run many of these on the same computer without even raising the suspicion that they're bots. Whole different playing field there. They left some traces when they patched this attribute on the prototype. People detected that on the screen. They found it. They patched it. They did this fast. Let's talk about something harder to fake: canvas fingerprinting. That's when you dynamically render a canvas to fingerprint your device alongside the browser. Sorry, should be harder to fake. Bam, these folks developed an extension that reports fake values using JavaScript hooks. So they solve pretty much anything. I want to take the time to explain just one of these before I fly through the others. You have Chromium here. When it's headless, it does not end the Chrome.csi, Chrome app, all that performance stuff. So think, okay, I can detect Puppeteer when it's headless with this. All of a sudden, not so fast, buddy. They fill every single object with fake values like this. Navigator Chrome, load times, runtime, apps, so on and so forth. Anything that can be used for detection and making it stupid easy to use. Annoyingly elegant. Remember CAPTCHAs. 2 lines here, a little bit of money, and they solve that. And all of this is going to be just with these 2 lines here. Everything we talked about, super easy to use. Bot tests failed to find it. They just hang this bot detection on their repo. But I promised I'd get to what actually works. That part, I made it within 10 minutes. All right. Obviously, I can't specify too much here, but let's start with the easy part. Easy bots are easy to detect. I'm going to name 3 ways to go after hard bots. This is going to be quick, but I'm going to say this more than what's out there. Starting with stuff like hardware concurrency, there's still more JavaScript engine artifacts to be found if you know where to look. These are becoming increasingly rare, though, so I wouldn't count on them long term. But the upside here is that they're very clear cut. What will hold all the time is behavior tests and session level data analysis. Behavior tests that still work usually look at window context discrepancies interacting with the DOM, and data analysis can take many shapes. For example, let's say you fake the user agent perfectly. The question is what value you put there. Look at this graph. That's the user agent along and navigating to an app. Each point is how many people navigated with that specific user agent. You'd say there's some variance here, but this is what it's supposed to look like. Blue line's almost flat, so that's probably because the bot fraudster got right how the user agents vary. They got the weight part entirely wrong. They're probably just producing these at random. Normal sites don't do this. And here's one way you can detect even the best bots. So at the start, I asked you, what's up with bots on the web? I can't tell you for sure, but what I do know is that they're getting better. We need more smart people like you to be aware so that the internet becomes a better place. Thank you, and feel free to reach out.
Hello everyone, and thank you for coming to my presentation. Today we are talking about performance is user experience, optimizing the front end for the user. My name is Chinaya Onwebu. I am a senior software engineer at HubSpot. What is software performance? We all know what software performance is, or at least we have an idea. This is basically a measure of how well your application is running, how well it's performing its task, and how well it's using the system resources that are available to it. On the front end, however, software performance is all this plus how the user feels about your application. So if the user doesn't feel good about your application, no matter how fast your application actually is, your application is not performing well. Because the front end is racing for the user, we measure performance of the front end in relation to the user. So we call this perceived performance. This is a subjective measure of how well your application is performing, how well the user thinks your application is performing. Perceived performance is very difficult to measure. You cannot measure it directly. There is no way to tell how a user feels about your application. There are ways to measure it indirectly. First is you can use bounce rates. If you get a lot of bounces, you're getting a lot of users that are dropping off after the first few seconds on your website, it's usually a sign that your application is not performing very well. Users think that your application is slow. Maybe the pages are not loading. Of course, it could also be some other problem. Maybe it's not the content that they are expecting, but usually it's a sign of poor performance, or users think that your application is performing poorly. Research has shown that users will abandon a website between 3 and 5 seconds after waiting for the website to load. So if your application does not show content in the first 5 seconds, there is a very high chance that you're going to lose a lot of users. So how do we actually improve the passive performance of our application? You can always improve passive performance by improving actual performance. First of all, you want to reduce the amount of time between when the user enters your website, presses enter, and when your website actually loads. So you want to use shared cache, for example. The shared cache is a cache that is shared between users. So if one user visits a page and this page is already cached, a second user visits the same page, the second user will retrieve a cache of this page. You can also use HTTP2. HTTP2 will massively improve your performance. This is especially true if your website loads a lot of resources. This includes websites that have a lot of images, for example, or websites that load a lot of scripts, a lot of CSS. HTTP2 will make loading resources in parallel to be much faster than HTTP1. You can also preload important requests. There are several ways to do this. Preloading important requests will make your website or your application feel snappier to the user. Using a CDN will solve a host of issues on your application right out of the box. Using Cloudflare, for example, will give you shared cache without you having to do anything. It will also give you HTTP2 without you having to do anything. Finally, you can use server-side rendering. Server-side rendering makes sure that when the page loads, that the user sees content immediately. So the user doesn't have to wait for all the JavaScript to load before they can see the content of your website. So using server-side rendering, users can already see the content, and then you can inject the script, hydrate the page later for user interaction. Then you can also improve passive performance directly by doing some tricks. These tricks do not change anything in your website. They do not change how your website actually performs, but they kind of change how the user perceives your website, how they perceive the application to be performing. And one of those is to avoid blocking the user. So if you are performing some CPU intensive task on the front end, let's say you're rendering images, you should avoid blocking the main thread. Always use worker thread for any task that will take more than a few milliseconds. The gold standard is 16 milliseconds. If it's going to take more than 16 milliseconds, you should move it to a separate thread. You should not block rendering. Blocking rendering is very easy to do and very difficult to avoid. But one simple rule to avoid blocking rendering is to only load the resources that you need at the beginning and then load the rest later. So in Webpack, for example, you can split your script into chunks, and then you can load only the important chunks first and then load the other chunks later or as they are needed. This way you will not block the rendering of the page. You only request what is required at the beginning. You can also avoid using spinners and use skeletons instead. Spinners make users think that your website is slow. It is psychological. They do not know what they are waiting for. They just know that they are waiting for something. When it's possible, try to use progress bar instead of just a spinner. Progress tells the user the actual progress of what they are waiting for so that they are not just left in the dark. Use optimistic patterns. There are a lot of resources online that explains what this means. When you use optimistic patterns, you mark a task as completed before it's actually completed. And only when it fails, you actually tell the user that this has failed. Gmail is a very good example of this. When you send a message, Gmail actually tells you that the message has been sent before the mail has been sent. It makes you feel as if Gmail is instant, but it is not. Don't block the user. This is a very common mistake. What does it mean to block the user? If, for example, a user submits a form on your application and then you show a full screen please wait spinner telling the user to wait until the form is submitted before they can continue. This breaks the user experience, and this makes the user feel that your application is slower than it actually is. Instead of doing this, you can show a notification, or you can allow the user to use other parts of the application while waiting for this form to submit. Finally, you should note and keep it in mind that the user expectation changes often while they are on your application. The expectation of a user that just arrived on your application is very different from the expectation of a user that is at the checkout page. New users are less patient than users that are already committed to whatever you have to offer. So you should keep this in mind, and this will help you. Thank you very much for attending, and hope to see you again next time.
Hi, thank you everyone for joining. I'm going to talk today about Blitz.js and how it's making full-stack web development a breeze. I'm Alexandra, the lead Blitz.js maintainer. You can find me on Twitter as Alexandra Says, so if you have any questions after the talk, don't hesitate to send me a message. I'm going to talk about 3 things today. Like, what's the Blitz.js goal? Why was it created in the first place? Then I'm going to talk about the Blitz.js framework and the future of Blitz. So what are the goals? So the main purpose of Blitz was to make full-stack web development as enjoyable as possible. We wanted to give you like the best developer experience in the world and make you as productive as possible. So with these goals in mind, let's see how do we achieve them. We're gonna start with a timeline, like what was happening during the Blitz.js development, how it started, and where it's going. So in February 2020, Blitz.js was created by Brandon with a huge help of the community. Then over the next few months, we got like tons of positive feedback. Like people loved it. People said that it's making them like really productive, and it also reached 11,000 GitHub stars. Last year in 2021, we decided to fork Next.js because we wanted to be more flexible and hook some Blitz.js code into the Next.js code. Unfortunately, we weren't able to move as fast as we wanted, and the weekly downloads kind of started to decline. So then we started thinking, like, what can we do about it? How can we bring Blitz to even more people? And how can we move faster than we did before? That's when we decided to, instead of having a framework, we can have like a toolkit. And instead of having you decide whether to use Blitz.js or Next, or Blitz.js or Remix, you can use a framework of your choice and some or all of the Blitz.js features. We started working on that early this year, and in April, during React Miami, Brandon for the first time announced the Blitz 2.0 alpha. So let's talk for a bit about the framework, how it looked like. So the core of the framework was Next.js, and then we had like authentication and authorization built in. We had Prisma set up, React Query, some utilities, like for example, to parse your data with Zode. We had recipes, the Zero API layer, which eliminates the need for using Fetch API. You can import your server code directly to your front-end components. We had code scaffolding, and we had like the app code again, so you can run Blitz new and the new app is generated for you. This is how it looks like. You can run Blitz new, my new app, and then we initialize the new project, we initialize the database, and you can start developing. This is how it looks like just after the new command. You have a new project, you have the authentication and authorization already there. You can sign up and then log in and start using your application. So now let's see how the Blitz 2.0 is gonna look like. So firstly, we have Blitz core. it's gonna have like CLI and variables loading, plugins, middlewares. This is where recipes and some utilities are gonna be. And we'll also have code scaffolding there. Then we have like a framework adapter, Blitz.js Next, which is going to export GSP and GSSP functions that you can use to wrap your get static props and get server-side props in your pages. And it will also have like a wrapper for API routes to be able to use Blitz features inside of your API handler's code. Then we have Auth, which has like the same authentication and authorization that Blitz framework had. It also has like a passport adapter for third-party authentication and configurable session storage. We also have the plugin for Zero API layer. You can configure your query client. It exports like React like functions like use query and use mutation that you can use for Blitz.js resolvers. So you can start with installing the alpha version and then running Blitz new. This is the server setup. So in Blitz Server TS, you declare what plugins you want to use. In this example, I'm using Auth Server plugin. On the client, you do almost the same. You declare what plugins you want to use on the client. So in the example on the screen, you can see that there is Auth plugin and Blitz RPC plugin. Okay, so we saw how the setup looks like. So let's compare the Blitz framework and the new toolkit. So all of the features that were there in the framework are also going to be in the toolkit, which is Zero API layer, authentication, authorization, new app templates, the code scaffolding, recipes. But in the toolkit, we have like so many possibilities. And there are so many things that we can start working on, like we can handle WebSockets, like cron scheduled jobs, job queues, some mailers integration, billing integration, maybe even GraphQL data layer. And we can also add better support for mobile app development. So that was a quick intro into Blitz.js. And if you want to know more about the toolkit, you can visit canary.blitzjs.com website. It has like all the documentation for the new toolkit. And if you want to check out the old documentation for the framework, you can visit blitzjs.com. Also, you can check out our repository. It's in Blitz.js organization under Blitz. Thank you a lot. I hope you enjoyed the conference, and don't hesitate to reach out if you have questions.
Those were some great lightning talks, and I hope that everybody is commenting still in the community track channel on Discord. A word from our platinum sponsor. AppWrite is a self-hosted backend as a service platform that provides developers with all the core APIs required to build any application, database, storage, authentication, functions, and more. You can go and build your dream app for mobile and web now. Get started on appwrite.io. For our next session and our next speaker, Brandon is joining us. Brandon is a developer experience engineer at AppWrite, focused on community engagement, content creation, and collaboration. Brandon's talk covers building web application with JavaScript through the lens of Astro, which is a static site generator where the choice of JavaScript framework is uniquely yours. Please go over to the community track on Discord, leave your applause, leave your questions, and Brandon will surely reply to those. Brandon, the stage is yours.
The next wave of web frameworks is BYOJS. Hi, my name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts, where I tweet out GIFs, I talk about sports, and I block people sometimes. So you can follow me there. I am a maintainer on the NGRX project, which is a set of reactive libraries for Angular applications. I'm also a GDE, which just means I've been around the Angular community for a while and been able to contribute some cool things there. I'm also a developer experience engineer at Appright. So for the agenda for this talk, I want to cover the history and evolution of building web applications and the different stacks that I've used over the years. I'll talk about the next wave of web frameworks and sort of the meaning of BYOJS. And I'll talk about what that means through the lens of the Astro project. So first, I'll talk about the history and evolution of building web applications. As I mentioned before, this is from my point of view, which has spanned a number of years, and your mileage may vary here, so let's just get that out of the way up front, but I think we'll have some similarities along the way. So let's get into some of the history for building web applications. We have traditional server-side applications, which we'll talk about, client-side applications, and more modern server-side applications before we get into the next wave. So for traditional server-side applications, let's talk about some of those. There's PHP, which is still a favorite amongst developers. There's also another old school pick is classic ASP, which is similar to PHP, but using more of a .NET-like syntax. There's also .NET MVC, which is another framework from Microsoft used to build web applications with a more clearly defined separation between model, view, and controller. Express also came along as a way to serve up HTML application using various templating languages. And of course, there are many others that came along the way. These server-side frameworks did all the processing on the server and just returned the HTML. If there was any JavaScript functionality on the pages that we were building, it was more or less sprinkled in as inline scripts or lightly bundled JavaScript files concatenated together. This was usually done using the well-known jQuery library back in the day. So now we get into client-side applications. So when more JavaScript was being introduced into these applications, we started seeing more bundlers get involved in the process to optimize the process of shipping JavaScript to the users. Open source tools such as Gulp, which is a toolkit that uses a streaming build system. There's also Browserify, which one of the early tools that allowed developers to use Node.js style modules and compile and use them in the browser. It's Require.js, which is a module and file loader system that also uses Node.js style imports. And System.js, where it used standard ES modules that could be loaded in the browser. And with the evolution of web applications being built for client-side applications, more web frameworks came along the way. Web frameworks such as Backbone, which was an early MVC framework for building client-side applications. There's Ember, which heavily leans on conventions and integrations for building web apps. There was AngularJS that integrated in with existing HTML with things such as directives. Angular, its successor, which targeted more general applications. React, introduced in 2013, which really changed the way we thought about building UIs in JavaScript. And there's Vue that has come along and paved its own way as a tool to build web applications. And of course, there are many other web frameworks that have come along in this space. So for modern server-side applications that were built in JavaScript, in the React space, we have ones like Next.js, which is the largest React framework to date for building applications, and newcomers to the space such as Remix, which kind of combines some of the things from client and server together in a more cohesive way. In the Angular space, we have things such as Universal, Angular Universal to render client-side apps on the server. And for Vue, we have tools like Nuxt, and there are other ones in this space also. Modern JavaScript applications also brought the need for more advanced build systems. And so some of these systems just made it easier to bundle JavaScript to ship to the client. And this also made shipping full client-side applications a lot easier. Webpack probably being the most notable to date, which is with its rich set of plugins and customizability. There's Rollup, which is a module bundle for JavaScript that compiles small pieces of code into more larger bundles, such as a library or an application. There's also Vite that has come and taken the web landscape by storm with its speed and extensibility through plugins. And it also builds on top of Rollup and is built in a different language, but is used for building JavaScript applications. If you're in the monorepo space, there's tools like Lerna, which kind of orchestrates build tools and has been around for a number of years, and tools like NX that have modernized open source monorepo development. And there are others in this space also that have come along as build system or tools to help developers ship web applications. Because at the end of the day, we just want to get back to shipping code and shipping applications to users and providing good user experiences. So next up, I'll talk about the next wave of web frameworks and ways to ship applications with JavaScript that have come along. So we can start with the why we have this shift in traditional server-side applications to shipping only or the majority of applications using JavaScript and getting some of the new tools that are out there. One thing that really came along was the idea of or tools that let you measure performance for web applications, give you more insight into that process. There's also the rise of the Jamstack, which is, we'll get into what the definition of that is and how the different tools in that space. And what I'm calling, at least for this talk, the static first or HTML first web. We have tools that measure how quickly and how long it takes for a page to load. There are also lots of well-known tools out there. I'm using web.dev as a reference for the metrics that we use to measure this. Now, Lighthouse is a tool that you can use also to measure web performance for a given application. And I'm just listing some of the metrics we can use to do that. There's time to first byte. And time to first byte is a metric that measures the time between the request for a resource and when the first byte of the response begins to arrive. There's first contentful paint, which measures the time from when the page starts loading to when any part of the page content is rendered on the screen. There's also largest contentful paint, which is a pretty important user-centric metric for measuring perceived load speed because it marks the point at which the page load timeline when the page's main content has likely been loaded. There's also the time to interactive metric that measures when the page starts loading, when its main sub-resources have loaded, and the user is capable of responding to user input. So using these tools and metrics have allowed us to gain better insights on how we're using or overusing JavaScript in the applications. Larger bundles means more JavaScript to process, and HTML has always been the fastest way to get content to users. So we wanted to look for a better mix there. So what are some of the tools in the next wave of building applications with JavaScript? We have the Jamstack, and I'll talk about kind of what the Jamstack is and how it provides some tools for building web applications with JavaScript. I'll talk about SSG or static site generators, talk about server-side rendering, and then we'll talk about the static or HTML first web applications that are cropping up, or frameworks that are cropping up now to help us ship code. So there's the Jamstack, and the definition of the Jamstack has evolved over the years. It started out looking something more like this, where the jam and the Jamstack was, capitalized, and it talked about using JavaScript to enhance pages, APIs to most commonly use things like serverless functions for offloading data fetching from the client or integrating more code into the client there, and markup, of course, HTML for rendering content on the page. These days, Jamstack is more now defined as an architecture that's designed to make the web faster, more secure, and easier to scale. And builds on many of the tools and workflows that developers use to help them be more productive. And that's just coming from the jamstack.org page there for the definition. So static site generators are focused on pre-rendering, where the pages are rendered at build time and served on the client without any HTML included there. In the Jamstack, they're also focused on decoupling APIs and services from the client-side applications and enhancing these pages with JavaScript because the HTML is already rendered, instead of using the JavaScript to render the page in its entirety. There's also server-side rendered applications which fall in this space, where the pre-rendering is done on the server and then sent to the client. And after the page is rendered, the client-side JavaScript is loaded and rehydrating the page to make it more interactive. And this is also where we are still shipping a single or maybe a few bundles to the client to handle this in the client-side application. And as I mentioned before, this provides faster time to interactive metric if we're measuring the performance of the page itself. So each one of these tools have kind of moved in that direction of trying to get data, content and data as quickly to the client as possible. But we also mentioned that HTML has always been the quickest way to get there. So these new wave of tools are moving to what are called a static first web or HTML first web, where the primary way is rendering HTML and then adding some JavaScript in some unique ways there, or not even adding JavaScript at all for the different types of websites that we're going to build. Some of these tools include Quick, which is a relatively new HTML first framework that renders all the HTML using SSR, and only at a very granular level only generates the JavaScript that you need. There's also SvelteKit that uses server-side rendering with progressive enhancement to, like I said, enhance the page where you still get the benefits of HTML first and with the additional functionality there. There's also 11t, which was created as a JavaScript alternative to Jekyll. This also ships zero client-side JavaScript up front. Another tool that I recently found out about is called Eels. That's new in this space. And then there's Astro, which I'll talk about further, that is a static site generation tool that has additional integrations. As I mentioned before, Eels is relatively new and was kind of inspired by Astro. But the biggest thing we want here is balance, where we still get content to the users as quickly as possible while providing a rich user experience for web applications. So next up, I want to talk about this new static first or HTML first web through the lens of the Astro project. Now, Astro is a static site generator that also has recently added support for SSR server-side rendering. Ships 0 JavaScript out of the box when it's rendering the app pages in your website. It promotes things such as the islands architecture and uses partial hydration, which I'll get into further. It has integrations, and then we'll talk about what that means in the world of BYOJS, as I call it. So as a static site generator, you're dealing mostly with websites here. So you're building things like landing pages, marketing sites. There's also blogs, things that don't require a lot of user interactivity, or maybe just a little bit of user interactivity, and just making a just general differentiation between websites and web applications. As I mentioned before, Astro ships 0 JavaScript by default. So it uses server-side rendering or uses server-side rendering to render these components on the page. And it does that by stripping all the JavaScript, rendering the page at build time and stripping all the JavaScript away from the page and only shipping you back the markup so that you can use that with your styles to present that data to the user. Now, there are areas where as I mentioned before, it supports partial hydration. So there are areas where you will need some interactivity, and it uses that by only providing or only loading what's needed for the client at that particular time. So each specific component maybe has a certain set of JavaScript functionality, and these can include examples like an image carousel or an autocomplete search bar or even a mobile sidebar. These are things that when rendered on the client, you still want to have some JavaScript there to, like I said, kind of enhance that experience. And as I mentioned before, the islands architecture is the idea of using partial hydration to build entire websites. And this is an alternative to the common process of building a website like completely in JavaScript and shipping that entire bundle to the user, whether this be a single bundle or maybe a few lazy loaded bundles. But we still get those components loaded individually for the website or maybe a small web application itself. And all these things are loaded in isolation. In that way, they aren't connected to each other in any way, so they don't have any dependencies on what's needed to be loaded for those. So looking at an example page, we have some distinct areas here. We could have a header page where the header is loaded independently on its own island, a navigation bar on the side that may have its own subcomponents there, in the main area to display content for the page. And as I mentioned before, all these things are considered islands and isolated and loaded independently from each other. So this islands architecture, or the components in the islands architecture, also make use of these different directives. And these are directives that, when used on the components, they can tell you when the component is or when the page is loaded to load the component, when the component is actually visible on the page, to not load the JavaScript until that component is there, or if the user is browsing the page and they are idle, then to load those components. So it definitely making use of deferring that as far as possible for showing that or loading that JavaScript for the user. So what does this mean in terms of the the BYOJS that I've been mentioning during this talk. So BYOJS is bring your own JavaScript framework included there. And Astro does this through integrations. So Astro is different, that you can bring your existing knowledge of your framework of choice, and Astro knows how to integrate with those web frameworks and render those components on the page statically, and add interactivity to those components later when you need it on the client. So you get a little bit of the best of both worlds. Astro supports just about all the commonly used frameworks that support components out there, such as React, Vue, Svelte, Solid, and more. There are more that I've just listed here. They also have APIs that would allow you to potentially integrate any JavaScript framework into an Astro application. You can learn more about the Astro project at astro.build, where you can read more through the docs, learn more about the integrations, and see how it can help you build websites faster there. So definitely check that out. So to recap, I talked about the history and evolution of building web applications using server-side or traditional server-side, client-side, and applications and frameworks. Talked about the next wave of web frameworks, some of that are out there today, such as using the Jamstack and other tools in that space. And talked about the Astro project. You can find out more about Astro at astro.build to read more about the docs and get more interested, or even get involved in the project.
That was another great session. I hope everybody's joining our spatial chat and talking to the speakers. Then, meanwhile, gold sponsor Modest Create builds customer-centric products, processes, and platforms to help businesses succeed in the digital economy. Visit modestcreate.com to learn more about their services or apply to be a part of their team. For our next session, Nikhil is a software engineer at Postman based out of Bangalore. At Postman, he's mostly handling stuff around Postman's design system. If your UI is not usable by roughly 20% of the world, that might have some serious legal ramifications for your business. By investing in accessibility and accessibility awareness, we make our UI actually more usable for a great many more people and avoid lawsuits at the same time, which seems like a win-win to me. Please go over to the community track and leave your applause, encouragement, and questions for Nikhil, and Nikhil will surely join you there. Nikhil, the stage is yours.
Hey everyone, hope you all are having a great day. So I'll be talking about an interesting topic, that's building UIs by the people for the people. So before diving in, for those who don't know me, hey, I'm Nikhil. I am a software engineer at Postman. I mostly handle stuff around Postman on the web, Postman's desktop platform, and the design system at Postman. So I'll be there. You can connect with me via Twitter or GitHub. Come say hi. Would love to have a chat. All right, so before diving in, let's understand a small analogy, which I really like when introducing a concept like an accessibility thing. So imagine if there's a constitution of a country, it guarantees the citizens some rights. Let's say there's right to education, there's right to religion, and there's also right to expression. So stuff like that. Taking a gist out of the example of a constitution of a country, we can say that the constitution is the one that guarantees an equality of stature, regardless of what the background of a person is. Now, when it comes to accessibility, we can make some changes to the statement. And now the statement can say that, all right, accessibility also does the same thing. It guarantees us an equality of consumption of a user interface, regardless of what the disability of a person is. So simple things, simple put, accessibility just means that if I have a product or a service, accessibility would allow a person, regardless of any sorts of disability that he or she might have, to access the product and use all its features in like a seamless experience. So in our case, we'll be restricting this talk to only web content accessibility, but accessibility is like a far wider topic. We use like many tools to like have accessible experience for our users, which is like using screen readers, which can help us like announce what is there on the screen for people who have vision like a problem with vision. There's keyboard navigation, so that the ones who don't have a mouse or like have problem with like having a steady hand over their mouse cannot use it directly. So there's keyboard accessibility for that, but like we'll discuss more about it once we progress with the talk. So going ahead, you might already know that we already have accessibility there in the real world, right? So for ones who have a problem with walking, we have wheelchairs for them so that they can go around. We have a stick invented for people who have problem with the vision, or even we have braille scripts so that people who have problems with vision can read clearly. So if accessibility has so much of its importance being realized in the real world, so why would our JS world be left behind, right? So with this thought in hand, let's see two important concepts before progressing with this talk. So on the left, you'll be able to see there's WCAG. Now this term means Web Content Accessibility Guidelines. Now this is nothing fancy, but just a set of guidelines and checklists that have been put together by a group of people around the world. And these checklists help people make the content inside their apps more accessible and like more reachable to any sorts of people with any disability. Now on the right is just a subset of this WCAG, which we say WAI ARIA, which stands for Web Accessibility Initiative, Accessibility Rich Applications. Now what they say is that, okay, you want to meet WCAG guidelines. Now, okay, I have some APIs so that you can use in your code and you can meet those guidelines. So we already know that there are many such accessibility APIs like this. There's ARIA invalid, which says that, okay, screen readers will know that once an input is invalid, they can announce that on the screen. There's ARIA required to announce on the screen that, hey, there's this, you're on an input which requires a field. So there's stuff like that. And we'll see more about it in the coming slides. But yeah, just one thing to note keep a note of in mind is like especially related to the JSX or the React world, that we have this sort of an like a mental model that we have a camel case for every prop, but that's not the same with accessibility. So with these accessibility attributes, we just have to use them as it is that you have been using with HTML, which is like a hyphen separated values and not with a camel case. So just a small step there. And moving on to like why we should care about accessibility. Now, the very first and the foremost reason is you might be surprised to know that 15% of the world's population has some sort of disability. So if you're not making our apps accessible, that means 15% of a big chunk of our audience, which is a number that we can't ignore, cannot use our apps in the way that we want, right? And second thing is like if we have an application that is being gonna use like in multiple countries, it like has a reach over like the whole world. We might want to like see that there are countries which really like you can say like give importance to accessibility and like the people who are like they have some disability. For example, there was like a very recent case, right, which we all know regarding the Domino's website, where we, according to the Americans Disability Act, it was not compliant to the accessibility practices that should be there. So if you are creating a website and you are gonna go pan world, make sure to have these things in mind. All right, so with this talk, we're gonna bust up some myths for accessibility. For example, accessibility is just for disabled people. I wouldn't say that, because disability can also mean if someone does not have a mouse, that's also a disability. Like if we show a loader on a screen while something is still being fetched, that's also an accessible experience that we're giving to users. So the deeper meaning of accessibility is to cater to any sorts of disability and rather not just physical disability. So that's just a subset. And second is that accessibility is hard. I think we're gonna see this at the end of this talk that no, it's not. And accessibility is also not just about like blatant ARIA tags, and there's like ton of more practices that you can do so that our apps become more accessible. And yes, this talk is not an accessibility primer. This is not just a theory class. I would want to like make this more and more inclusive and like more demo driven, so that we, after this talk, we take a key takeaway of like what the deeper meaning of accessibility is and how we can get started without reading those big blogs on the internet, right? All right, so with all these thoughts in mind, let's get started. So the first and foremost tip that I give to everyone is using the right HTML tags, which usually wins up most of the battle for us for accessibility. Now, when we use the right HTML tags, our screen readers use that information to deliver the right context over like what is there on the screen. For example, if you're using a button HTML, the screen readers can tell people that, okay, this is a button. And it also, like, these HTML tags also give you like some wins baked in. Like, for example, you don't have to handle tabbing order of like your buttons or like inside a form. If you're using many input elements, you don't have to think about like what should be tabbed first, what should be tabbed last, where should be the focus line first or not. So this is like all baked in once you use the right HTML. And also, accessibility can also, like, if you want to extend this definition of accessibility, you have your peers who are using the same HTML structure in their daily code base and they're working onto it. And if you use like something on the left that you see like a big list of divs, it might be a hard time for them to like, they have to just open each of their div. They have to find out, oh, this is like a header div. Oh, then in this div, okay, there's this main section here. In this last div, oh, this is a footer. Okay. But on the right side, if you see, if we are using right set of HTML, it not only gives screen readers a good experience, but it also gives your colleagues and your developers to find out what's there in like each and every part of your app. So there's just a small chart to help you find out like what does each area and like what should be the semantic tag for every area should be. Like, for example, the topmost thing should be a header. There should be a nav tag after the header that should show navigation and stuff like that. And accessible JSX, as I already mentioned, is like not accessible HTML. So like I usually like see some queries from people that they say that, hey, I'm using these 3 things as you mentioned, Nikhil, but I'm not still having accessibility. So I would say that there's accessible HTML that should be implied to your accessible components, like header and main on the left. That should make things accessible. So another thing to keep in mind. And let me also give you a small gist of like, we are also the ones who make things difficult for both users and like also us, right? So let's imagine a case where we have a div, and on a click we just have a function which will handle stuff when this div is clicked. Now this is giving a simulation of button, but now you will say that, hey, my screen readers are not reading this. They read this as a div. How do I tell my screen readers? Now you'll say that, okay, we have ARIA tags. Let's give it a rule as button. And we'll say, oh, that's fine. Now I've solved it. And then you'll say that, hey, but it does not give me a tabbing experience. How do I show that a particular focus comes in when someone is there on this particular div or a button when someone clicks it? So we will say, okay, there's tab index, you have to give it a value 0, and you have to do all of this mumbo jumbo, right, when you're not using semantic HTML. But the reality was like super simple. You just had to use something that was just a button tag, and all of that came out like baked in for you. So if you're using the right HTML, you also have lesser work for you and lesser work for screen readers itself. All right, coming into the next topic, that's keyword accessibility. Now, as the name already suggests, keyword accessibility simply means that your app should be usable and you should be able to interact with any part of your app by just tabbing in, like without using a mouse. You should be able to use it. And that means that there should also be like no keyboard traps. Like if I like keep pressing tab, it's that I should be able to go to every part of my app, like every part of my screen, and like not just I just like keep revolving around only 1 or 2 buttons and inputs. So that's just basically what it means. Now, why is keyword accessibility important? The first and foremost thing is like, if like there are people who have problem with vision or like who are like blind, they usually rely on keyboards, and like when they tab on things, they rely on the screen reader so that the screen readers tell them where exactly on the page are they. So that is really important. And also, like if someone is like not having a vision with a problem with their vision, there is a problem with motor disabilities where like if someone is using a mouse, they are not able to have a steady hand, and like they have a problem with like interacting by a mouse because their hand is not steady. right? So that's also when keyword accessibility comes into picture, because they have to rely on a keyboard. And thirdly is like, as in general also, right, we all love keywords. Like if you're also seeing like in this slide, I'm using more of a like my keyboard's navigations to go between the screens rather than all the like the mouse and the trackpad, right? So it's like good to have keyword accessibility in your application in this way. So, and like there's semantic HTML for the win here itself, because I am using, like in this small demo, I am using a login form, and in here I am showing that once I tab, I'm like not using any mouse. I'm just like simply tabbing over elements, and I am able to go to every right set of my HTML in like the right order. So there's semantic HTML for the win. So although like a browser gives you a default focus, like I think as we just saw in the screen, so like the browser is giving us like a default blue color border on every element, but we can like make it customizable and like more vibrant, because we want to make our websites look more beautiful, right? So you can use a focus pseudo class in this case and apply a border, or like you can add a box shadow in those cases to make your focus styles more better. There can also be a case where like you have an input form and you want to focus by default like specifically one input field whenever a form loads, because that's a better experience, right? So in that case, although this snippet is like more focused towards React, but you can use that in JavaScript itself. So like using this use effect hook which you have in React, you can use a ref of that particular input, and using that reference you can focus it at the time this page loads. Now, coming up to the inputs and the labels, it's always a good practice to use labels, and those labels should point up to your inputs. Like whenever someone clicks on a label, the input element automatically gets focused, which is like a very small thing, but a good user experience. So there's an HTML4 attribute that one can use. So that's a very simple thing and a one-line code to add. Now you'll ask me that, hey, Nikhil, there's not every time that I will need a label with my input, right? So in that case, my answer would be still have a label, but use a class to hide that label from your screen. But that label should still be rendered into your DOM. So I have this class called visually hidden, which I'm using to hide my label, but my label is actually there in the DOM. It's rendered because screen readers are still going to see what's rendered on the DOM, because they want to announce what this input is all about, right? And they're going to make use of that label. All right. There's like also a bunch of ARIA level tags that you can use. For example, there's ARIA invalid true, which gives which lets the screen readers know that, hey, your input is invalid, and they can announce it on the screen. And again, like accessible forms have a ton of other input elements like field set, legend, so that they can give more information about the forms. Now coming to navigation. Navigation is also like very important, because now in our case, we have so many like nested level of spas, and once we are like in deep down into like in a flow, we want to see like exactly where we are, and like we want to navigate faster. So there's when like navigational elements like breadcrumbs come into picture, right? So coming up to this, you would want to handle a navigation to a main content when it comes to a tabbing experience, right? So like if someone is tabbing and you have a lot of links in them, some users might not want to go to those links. They directly want to switch to the main content of your application. And that's where we can like just insert an anchor class, an anchor tag, and clicking on that anchor will directly skip our tabbing experience to just go to the main content. So that will be like another user experience for those people who are just relying on keyboards. All right. Coming to accessible SVGs, although like, yes, we already know how to use SVGs, but using a title and a description attribute inside them can help screen readers know what this SVG is all about. So like when announcing, they will not go haywire, but they will know a small description about it. So it gives users like a meaningful picture about, okay, what this image is, or like what this SVG is. All right. So using a document title is like a very small thing. We usually skip this, but it's a very important thing. So once we have inside our spas, which like a single page applications, like be it in JavaScript or React, although our page is changing, but our document titles usually remain the same. So we also want to keep changing our document titles, because our screen readers are also going to read it. So like, let's say again in React, you can use the component did mount, or like you can also use hooks to change the document title. Like every time you like change the screens, or like every time you think that you're going from one page to another page. So that's a better user experience. There's also a library called like React document title that you can use. And I feel like it's like much more declarative, but you can use any of those approaches. It's totally up to you. All right, with this, I think I have like shared like a few ideas with you, and there's all like, again, like accessibility is like although a very long thing, it's a long journey, but with this talk you'll be able to get things started, and you will have like, I think most of the things like you will be able to be in a position to start migrating your screens and using like starting to develop some accessibility practices in your apps. There's also like a ton of examples that like I wanted to cover, but I could not due to the time. There's like textual content that should be like precise and clear to people who are like not having the right vision. There should be internationalization in place, because people who are across like different, like who live across different areas of the world, they don't have the same language. They might be like other sorts of languages that other than English that they want to use the app in. So if our apps are converted to the same language according to the region, that makes it like more usable and more appealing to people. So there's like another like ton of practices. So I would say like if anyone's interested, go ahead and deep dive into these concepts. All right, so with this, let's quickly see a demo of like a same login app that I had created. I'll just first show you what the screen reader will announce in this app, which does not have any accessibility in hand, and then we'll see like after applying these practices that I just discussed in the talk, what was the change to like someone. So just close your eyes and like try to see that what you in the space of a blind user or like a visually impaired person would see, or like when you are typing in this form. So all right, let me just start this recording.
App web content. Heading level 1. Login form. https://www.mindinventory.com/blog/wp-content/uploads/react.js-benefits.jpg image. Enter edit text. One password. Enter secure edit text. Visited link. Learn more. Chrome has new window. Visited link. Contact us. You are currently on a link. Inside web content. Voiceover off. App web content. Heading level.
All right. Let's minimize this. So yeah, although I think
app web content heading.
Okay. Whoops. Yeah. So basically, now you would see like the image name is like being pronounced up to like its length, and I'm like not getting some meaningful information about like where exactly I am. Now let's try to see what exactly is the experience now after we add some accessibility. Okay.
Software. Yes. Entering React Good early demo web content. Visited link. Skip to main content. Visited link. Skip to main content. Chrome main. Login form banner image. Enter username. Enter require edit text. Enter password. Enter require secure edit text. Submit button. Visited link. Learn more. List 2 items. Visited link. Contact us. Heading level 1. Login for main. Login form banner image. Enter user.
All right. So seems to be slightly better, right?
Software.
So, all right. So I think that we have been making some progress. Another like some small things to mention. I really like this tool called Axe DevTools, and I would really recommend anyone who has been handling accessibility use this, because it not only shows you the error, like in terms of the accessibility practices that you've been doing, but also it also gives you a fix up to that. So and like it's also very descriptive. So I really love this. So would advise like anyone who is interested to use it. All right. So with this, we would want to end our discussion, and there are just like some links that I've added, which are related to both the demos that I had actually added, and also the link to the slides, which I'll anyway share with everyone. Some of my personal favorites that I think are like a very good reads other than this, and would also give you like more knowledge around like some other things like which we could not discuss in the talk. So feel free to go ahead with it. And yes, let's make our web content more accessible for everyone. So I hope with this talk, you would be able to get some insights out of it, and you will be able to use now accessibility into your apps. On a side note, we at Postman are also like fascinated about technologies at React and also like accessibility. So if you would want to come join us with this journey of like building something cool, feel free to reach out to us at our careers page, and we'll be glad to connect. All right, with this, I rest my case, and thanks a lot for having me out. Thanks.
And yet another great session. And you'll have a choice to make. Either you go to Spatial Chat and talk somewhere with our speaker, or you join the discussion room on Web3 and blockchain going on right now. The choice is yours, I guess. A little word from our gold sponsor, Snyk. Snyk is the leading developer security company. Develop fast, stay secure, find and automatically fix vulnerabilities in your code, open source dependencies, containers, and infrastructure as code with Snyk. For our next session, Sam is joining us. Sam is a former Googler and now the CTO of an energy startup in Australia. With Dialog and the inert attribute landing in all major browsers in 2022, we as web developers now have a simple yet powerful primitives to help build complex app-like flows on the web, rather than the over-engineered or leaky solutions that we've relied on for years. Sam aims to demystify these primitives with us and talk through how they make your code simpler. So from plain HTML, web components to React and similar. Go to the community track and leave your questions. I know you have a bunch, and leave your applause for Sam as well. Sam will surely reply to everything. Sam, the stage is yours.
Hey there, my name's Sam, and I'm here today to talk about ensuring your users are on the right path, the futures of modals, and focus management. Now, that's a handful, and I submitted this talk to JSNation a while ago, and since then, I think what it should be called is basically focus management in 2022. Now, the web has come a long way, and actually, for the first time this year, all the evergreens are supporting these amazing new features that we can use as either primitives or as part of some greater library. So, firstly, what is focus management and why do you care? Now, I feel like this is the quintessential reason of why it's important. Now, we've got a dialog here, I can click around, I can hit submit, but what I can actually do while this is operating is press tab a bunch of times and get behind this UI. I can still click some buttons that are on the page here. Now, this is a demo, but lots of sites have this problem if you look around. And the challenge is that it's just really hard. And for the longest time, we've got libraries and polyfills that try to really maintain this, to try to solve this problem for you. But either they're not used correctly, they just can't do what you want them to do, or people just forget and they just use a really basic mechanism and hope that users will never get there. And this example is obviously pretty tricky, not everyone knows how to tab behind UI elements, but this kind of problem will leak out in other ways, causing users some weird behavior, and some examples here. To be very precise, the things I want to talk about today are dialog and inert. Now, these are the two new concepts that are actually available in browsers this year, and they're both quite cool. They're actually quite old in terms of specs. They were written a long time ago, but as I've mentioned, it's the first time that you can use them in pretty much all evergreens with no hassle. So before we go any further, who is this guy? Why am I talking to you? I'm a former Googler. I was there for over 10 years. It was obviously really fun. I was on the developer relations team, and so part of my job was to do this kind of outreach. I've actually recently left Google and gone to a small early stage startup in the green energy space called GridCog. It's a lot of fun. I would highly recommend working in climate. It's an important thing. And I'm always happy to talk to people about that, orthogonally to the content of this talk. Having said that, our technology is still on the web, and so we want to use these features even in our SaaS product to make our users' experiences better. And my general vibe of why I'm coming here and talking about these concepts in general and why I want this in my browser and why I want this in my web app is that to me, these new features are letting us throw away tons of old code that did weird hacks and horrible things to browsers that really they weren't designed to do. So having new primitives in 2022 is really lovely, right? I can get rid of all this code and get on with the more interesting parts of my job, right? Not dealing with focus management, but actually writing applications that do interesting things. So the first component I'm going to talk about today is called the dialog element. Now, dialog can do a whole bunch of stuff. The spec is pretty wide, but the reason why we most care about it as web developers is I can create this element on my page wherever I like, and then call show modal in JavaScript. What this does is then creates that dialog in what's called a top layer. Now, the top layer is special. It does two things for us. One is that I can't tab behind it. This focus problem has been solved. While it's visible, I can't interact with anything below it, including other dialogues that I previously opened. The second thing that's really cool here is that it actually exists outside the browser's kind of normal rendering layer. It's in a thing called the top layer. And what that means is even if you're inside some weird stacking context or your Z indexes are all bizarre, then actually the dialog will always be on top. I actually like to demonstrate this by, if you can see here that I've got this weird element that's transformed in bizarre ways. If I click this button, the dialog is actually inside this transformed element, but the browser's just going to ignore all of that and hoist it to the top. So in that way, it's quite cool. It's scoped and encapsulated in a way that you can use it in a component or some library, and it will still appear right at the top, ready for the user to interact with it. Now, that's the most interesting part of the dialog for me, but there's a few other things I want to cover before we go on. One of them is this backdrop element. And so every dialog for free will have like a full screen element. You can change its color or background or whatever. It also has a built-in handler for the escape key. Now, this is kind of bizarre, but kind of reflects when it was created back in 2014. But if I can hit escape on my keyboard now, then this dialog will close. And that's fine, but a bit weird because there's no analogy on mobile or other platforms. You can't press your back button on your mobile phone to close it. That will still, unfortunately, go to the previous page. There is something coming in the pipeline called Close Watcher as a bit of an aside, which is totally in draft state at this point, which does help deal with things like closing dialogues. And in fact, it's one of the examples called out in its description. But who knows if that'll come about. My advice, honestly, is if you don't want this behavior, you can actually add an event handler for the cancel event, and then the user hitting escape will do nothing, right? And you can control that keyboard interaction, or maybe you close the dialog with buttons. You can do that entirely yourself. The next thing I want to talk about is inert. Now, this is a whole different feature. Has nothing to do with the previous dialog, but it also lets you build interesting apps together. This is something where I can mark any subtree of my DOM to be inert. Now, what this means is I can't click on it, I can't interact with it, I can't tab into it. This is basically like a better version of pointer events none. And that's something that people often use, right? They just say, well, I can't click on this area, therefore you can't use it, right? Well, no, as you can see in my example before, it's very easy to tab behind that area. So inert basically gives you that for free, but also makes anything in this space just unusable. Now, this is a very broad primitive, right? I'll go through some examples later on, but it's worth thinking about, right? You can build a lot of things with it. One interesting downside is that you can't actually turn it off. So once a DOM tree is inert, that's it. I can't make some subsection uninert. Now, whether you think that's a feature or a bug, well, that's up to you. But to me, it's kind of a feature, right? If I have a component system and say, well, everything within me is turned off, something within that system can't say, oh, no, I really want to be turned on, right? So it turns everything off all the way down. And so the last component I want to talk about is actually quite ancient. It's the field set. Now, you might think of the field set as just some nice way to group input elements together, but what you don't know, or what you might not know, is that you can actually set disabled on the field set. What this does is kind of like a lesser version of inert. It's going to propagate that disabled down to any HTML form elements within the field set. So links will still be clickable, but like an input or a button will be read-only and disabled. Now, this is actually not as good as inert, right? It does fewer things. Inert's not quite there yet in Firefox. It's in nightly, which means it's probably going to ship soon. But this is like an interesting fallback that you can use if all your problem is just submitting a form, right? I don't want users to be able to muck with a form while it's in progress, and I don't want to modify every field. I can just wrap it in a field set and say disabled, off we go. It has one weird nuance with Shadow DOM, but it's possibly a bug more than a feature in that it doesn't propagate through to elements within a Shadow DOM's shadow root. And so one of the reasons I'm excited to talk today is that these three elements just work. Firefox, Safari, and Chrome support nearly all of these features. As you can see, and as I mentioned, Firefox is slightly behind on inert, but honestly, by the time you watch this talk, it's probably going to be there. You can just start using this stuff. These are primitives, though. You can use them directly, that's fine. You can also think about using them as part of a framework or a library. And I fully expect some libraries to basically have a fast path where they just say, we've got this amazing new feature, we don't need to do our old weird hacks, we can just leverage inert, dialogue, or even field set, although they might be doing that already, that's quite old. Now, with these amazing new primitives introduced, it's worth talking about how we've gotten here. Now, browsers were written for an ancient time where documents were documents, right? You clicked on links, you could go to other pages, and there was no app-like experiences in sight. But as we've added more functionality to the web and made it this amazing platform to build interesting stuff on, we've needed to control its focus much more distinctly. The tools people have had available over the years are things like literally just removing links, making a button disabled one by one. I mentioned pointer events. That came with IE 11, and it was sort of a new era in trying to railroad or guide people through your application in like a nice, friendly, organic way. And so the challenges of doing things like inert or disabled was that pointer events, as I mentioned, can be really trivially escaped, right? I can't just hide an element behind a div. I could manually set elements to input disabled or, disable the href on a link, but you've got to do it for every single one. What if it was already disabled? What if you're in a shadow root? What if all these what ifs, right? And polyfills make this kind of better, but they're horrible hacks, right? And one of the challenges with these things is I can't really intercept the user's intent or goals globally. Now, these new primitives we have actually let us do that in a much nicer way. And it's also worth calling out that making a dialogue without a built-in primitive is also quite challenging. The biggest one being, it's often not clear whether you can hoist yourself to the top of the page. Does position fix do what you want at the position you're currently in? And as you saw from the demo before, with the actual built-in dialogue, that's no longer a problem. I can just have a component that makes a dialogue and it will just appear on top, which is pretty much what I always want when I encapsulate elements together. Frameworks, I will say, can help. And if you're building your app entirely within a framework like React, then dialogue, may be a solved problem for you. I know that when I write React code, then we use a library that will actually hoist that element to the top level for you automatically, right? Like the fact that it's a dialogue within my React component is sort of irrelevant, right? It gets rendered somewhere else anyway. But some frameworks don't allow that. Some layouts, are never going to support that behavior. So having a built-in dialogue primitive is quite lovely. In general, the thing you're trying to avoid is fighting against the browser. As I mentioned, browsers were fundamentally designed for documents, not apps. One thing polyfills try to do is intercept and override every single focus event in totally weird ways. But it's futile. There's always more cases. So now that we've got here and I've given you a bit of a history lesson, let's talk through some of the reasons why you might use these components. Now, inert and field set are pretty much good for controlling forms and controlling parts of your UI where users shouldn't interact with it after something is done. And so in this example, I've got this quite fancy form, and when I hit submit, I can block it all out almost immediately and say, don't muck with this, I'm, processing a payment or something like that. I can even overlay a div on here showing that my cancel button or some behavior that I really want users to flow through. And what's important here is I don't have to muck with the underlying form, right? I don't have to worry about disabling things. I can just mark the whole thing as inert and create some new interesting state for my users to be in. Now, this is a subtree. Maybe I can do it for a sidebar or a larger part of my app that the user shouldn't interact with for some time for whatever reason. Now, you can go away with this talk and create some interesting experiences. And I've got some ideas here, but I think these are wonderful primitives, right? I think we'll see over the next couple of years people using them in vastly different ways. So now let's talk about dialogue. And it's worth saying and getting out of the way, I'm not a fan of you using a real modal or even a giant div for blocking interstitials, things like sign up to my newsletter when I really just want to read your content. I think we all as web developers know that's a terrible anti-pattern. But having said that, there are going to be cases where we do need to show a real modal on your web page. That can be because the user's, saving some state that you're confirming, do they want to leave? Are they sure they want to cancel? And in this example here, we've got a pretty good, nice dialogue that shows, the user's typed some document content, but they aren't sure if they're ready to finish or whatever. And so we give them a few options here that make this experience feel quite nice. We've got a close button to get rid of it. We've got a cancel button. And we can use this modal in an interesting way. There's a lot of stuff going on behind the page here, and the user doesn't have to worry about it. They can just be focused on one thing for a given amount of time. And modals, really shine in this example. Now, another thing we can do with the dialogue is also animate it. In the end, it's a div, right? It's a fancy div that has some magical properties and it renders in a weird place, but it's a primitive that I can use in any way I like. So when I show a dialogue, I can combine this show modal call with perhaps I'm going to start the dialogue off screen. and then let it animate it in over a second. One interesting thing I can even do here is maybe disable the interaction on the dialogue with inert during that time. Now, maybe a second is too long, but you get the idea. Similarly, when it closes, yes, there is a built-in close method. Yes, there is an escape handler, which I can prevent from happening. And when a dialogue closes, I can not actually close it for the same amount of time. I can say maybe for a short period, it animates out. And once that is done, I then properly actually close it. In the end, it's just a primitive, right? Like, I should be wrapping this behavior up in some other component or helper that does this for me, because the close method is not something that a user should necessarily call directly. It's something that you can control. So I'd like to finish up this talk by talking about some other things dialogue can do. I think it's worth being complete, but I will be clear, I think these things are the least interesting part of dialogue. Now, for a bit of backstory, right? Chrome introduced dialogue in 2014. That's literally 8 years ago. And Safari and Firefox have only just come to the table and built that feature out. And that's great, right? That's why the talk is here today. And I can say, please go and use dialogue. It's available everywhere. But I will say, some of its weird features were built for kind of a different part of the web. Now, it has non-modal support. I can just toggle this open attribute and dialogue will appear and disappear, but it doesn't block the page, it doesn't render in weird ways. And so it's kind of pointless, right? It's just a div in this regard. It also allows a thing called form method dialogue. Now, this is kind of cute, right? You create a form and when it's submitted, it'll automatically close the dialogue around it. But the reality is, what we do for every other form on the web today, or we want to intercept it with JavaScript or whatever, is we literally overload its submit method and then prevent default. Now, I don't know why form method dialogue exists when I can literally do this to a regular dialogue that has an implicit form method that I just disable or ignore with JavaScript. In fact, I'm already using the dialogue with JavaScript. So it's bizarre to me that we have this weird dialogue type form that sets a return value on the dialogue. Now, you might find it useful, but honestly, I think it's part of a spec that hasn't really aged that well. So I'm only mentioning this stuff for completeness. I don't want to end on a downer, right? Like, the thing to take away from this talk is that dialogue is an amazing primitive that gives you a modal experience that can be used in a bunch of ways, but which exists in the top layer, can be nicely encapsulated and used in components, and hopefully will give you the thing that you've wanted for a long time, but have maybe feared the reams of JavaScript or the horrible hacks to get there. And Inert's very similar, and even field set, if Inert's not available because Firefox is a little bit behind the fold, will also give you most of that functionality, right? You can quickly disable forms, and while it sounds like a really silly thing to have to be able to do, it's quite nice to have in your toolbox. So I hope you'll take away and go and run with these ideas. I will say one thing I haven't mentioned extensively is accessibility, or really at all. Now, all these things will kind of do the right thing, but I would encourage you to go have a read if this is important to you about how these things interact with the accessibility tree. I'm not an expert, and I don't think you should just use these features without any knowledge of that. So thanks for listening. I'm on Twitter. You can follow me in a bunch of places. I regularly blog about this kind of stuff. You can see my blog here and, subscribe to it with your favorite RSS reader. And thank you for JSNation for having me. And hopefully I'll see you around on the internets. Farewell.
Thank you for that amazing session. I learned heaps. Now, for one of our sponsors, gold sponsor Contentful is the leading content platform on digital-first business. Thousands of brands rely on Contentful to create and manage digital experiences across any channel faster and at scale. And our next session is by Jonathan. Jonathan is a tech lead and coach at Tieto UK, passionate about improving developer experience and building web apps without frustrations for both users and developers. Jonathan will share with us how to use gamification to improve quality on your project. Please go to Community Track and leave your questions and your applause, your encouragement, your compliments, everything. And Jonathan will surely reply to those. Jonathan, whenever you're ready.
Hi everyone, welcome to my talk on using gamification to improve quality. A quick word about myself. I'm Jonathan Wagner. I'm an engineering manager at Tieto UK, and I've been working as a tech lead for the past 4 years on about 10 and more projects in production. And I can tell you, I've always struggled with finding the right balance between pushing for fast delivery and having a good code quality on my projects. And I've seen both extremes, like project with 100% code coverage and project where just going straight to production without testing anything. So it's always been a struggle, and I want to talk to you about all of this. Something classic that people say in software engineering is that there are three hard things. You have cache invalidation, naming things, and prioritizing code quality. What do I mean by code quality? Let's dive a bit more into this. It's everything that contains technical debt, maintainability, refactoring, and so on. So it's finding the right balance between delivery and quality. But it's also deciding when to do the fix for the root cause versus the quick fix. Ideally, you want to do both, but maybe in the right order. So prioritize the quick fix and then invest time in looking to the root cause and preventing the issue from happening again. But that's the first question of prioritizing. How do you then improve it? It can be quite complex. I've started to develop a theory on this, and I'm going to try to explain this to you. So let's start by trying to split the problem into smaller parts. So let's say you have a code base and you want to improve quality on it. First thing you can try is to look at the new code you add, and then after that focus on the legacy code. So first of all, the simple part, the new code. You can start by creating a new standard, training your team with this new standard, and then making it hard for people to write bad code. That's an important step. That's a step you can automate. And to automate it, you can use tools like JSNit. It's not the only solution. It's definitely not perfect. It doesn't catch everything, but it helps prevent bugs. And often when analyzing the root cause of a bug, you can identify that a JSNit rule could have prevented it. So it's a good occasion to add a new rule, train your team on it, make sure they know how to fix it, and bit by bit, do something about it. And that means the new code you write has a better standard, and hopefully you improve the legacy code as well. But this legacy code, it's hard to decide when to look at it or not. And it's even harder to motivate everyone in your team, or multiple teams if you have, to look at it. So that's when it gets tricky. What do you do there? So let me tell you a little story about how I approach the problem and explain some of the things I've learned along the way. So, little story. We'll explain you in what state we started in, how we played with the CI and gamification, and then what happened and what kind of results we had. So initially, we had a project with about 1,500 warnings, so quite a lot of warnings. And this number was decreasing very slowly. So every time developers were adding features, it was known that they shouldn't be adding new warnings, and pull requests would be blocked by the tech lead or other developers in the team if they saw the number increase. That means there was a place in the code where you can say, okay, this is the number of max warnings, and if it changes, it has to go down, it cannot go up. But then in some cases, we broke the deployment pipeline. That would happen when two amazing devs would want to decrease the number kind of at the same time at a different pull request. So let's say the first developer fixes 2 warnings. So it means the max warning is now 1,498. And then the other developer opens another pull request, fixes 3 different warnings. That means he gets the max warning number down to 1,497. First one merges, everything goes green, all good. Second one merges, didn't rebase beforehand, everything was green without any merge conflicts, and boom, it breaks. Why does it break? It's because we now have -5 warnings instead of the expected -3 or -2 that we had before. And that means everything's broken, someone has to own the fix. People are not sure why it's broken, you might not have the alerting, it might take forever to fix. So we want to avoid that at all costs, and one way to do this is to basically remove warnings. Let's say we don't want warnings anymore, we just want errors. That's one way to look at it. That's what we tried. So basically, I went into the ESLint config, repressed all the warnings by errors, and overrode the one that were defaulted by the plugins we had. And we went from 1,500 warnings to 0, but then we had the same amount of errors, and that meant our CI was broken. But thank God, we had a little tool that already existed, which is a lint config generator called Clinter. It's open source, you can use it as well, and it helps you automatically add ESLint disabled comments everywhere you have an error. And that means we don't have any more errors, the CI was green again, and we never had any more merge conflict like this one. So first step, quite simple, straightforward, fixes everything. But then we have the problem of decreasing our warnings. So that's when I started thinking about, okay, let's try to automate this. Let's try to put kind of a little incentive in place. Let's try to make it like a game with a leaderboard. So I went on it, spent a little weekend coding, and came up with this. So the GitHub action could be adapted to SQL CI, GitLab, or any other CI tool you use. It's quite simple. It's basically posting a comment on your pull request and it telling you how many points you've earned in the pull request, how many points you've earned since the beginning of the week, and your current rank for this week. And you can see the podium, the full leaderboard, and the explanation about how to earn points. Basically, what happens is it's taking the git diff on the pull request and then counting how many lines you added that contained an ESLint disable and how many lines you removed that contained an ESLint disable. And then based on this, we get the score, compute the score for everyone as well, and print the leaderboard. No need to store anything anywhere. It's just computed every time you open a pull request. Takes less than 10 seconds, and that's the job just well. So I put that in place. I was super proud of myself, released it. First week, so many bugs. Lots of pull requests had 0 points when people should have had points. People complained, people weren't happy. I worked a bit on it, and after that, it was a smooth ride for the next 3 months. So here's the data for the 3 months on the project. So we started at around 1,600, and then you can see a few new ESLint rules added, and overall, it looks like it has increased quite a bit. But let's zoom in a bit more and see what happens. So first zooming in on the 3,000s and then adding some baselines, we can actually see that apart from a couple of weeks in April that were a bit bad, at the beginning and at the end, we had some good times. And let's do a bit more computation on that. So if we forget about every rule we've added, we actually decreased our number of errors by 235 in about 3 months. So that's a rate of about 78 per month. And assuming we now start at 3,500, means it would take us 4 years to get down to 0. We can do a bit more math and be like, okay, 78 per month. If we have a team of, say, 35 developers, that's about each dev fixing 1 error every 2 weeks. It's definitely not a lot. You can probably expect them to be fixing like 2 bugs in a week. And that means divide by 4 that number. So it means in 1 year we could get down to 0. So is it good? Is it bad? What do you guys think? That's the kind of question that we were asking ourselves, and that I can, again, explain what I've learned. First of all, should we aim for no errors? Is this something we should be, like, should we fix everything? Should we go down to 0? My opinion is that when you touch legacy code, you might introduce new bugs because the code is working, it might not be well tested, and by touching it, you just increase the chances of introducing new regressions. So aiming for no errors means probably inserting new bugs in your code base, and it's like the complete opposite of what we want to do in the first case. So maybe that's not actually the goal. Maybe we just be like normal to have a slope that is quite good at the beginning, and then after a while it stabilizes and it's normal because the new code is up to standard and you don't need to fix anything more. Something else that you can think of then is how do you make sure that you get into that new situation as fast as possible? And how do you detect when you get there? So maybe you can improve the tool. Maybe we can add new features like making sure we block the pull request to prevent people from adding new errors. Could be showing potential points by looking at the files that have been touched. So if we look at each file and how many warnings they have, then we can say, okay, had you fixed everything in there, you would have won 20 points instead of just 3. And then we can also show the total weekly diff, so that every week you can actually make sure that the number is decreasing and not staying average like we had in April. And maybe there are other alternatives. Maybe we shouldn't be just looking at ESLint. Maybe we could be looking at tests and making sure that when we add test file, we earn points as well. Maybe we could also incentivize people a bit more, like people earning a prize when they get first place. Or you could also like put the leaderboard on the TV for everyone to see it at all time and make sure that it's present in everyone's mind that it's a priority. But then that depends on, is it actually a priority? But then most importantly, was it fun to code? Definitely. I had so much fun coding this. And I really hope that you guys start trying it, contributing, and setting it up on your project, playing with it, opening pull requests, and improving quality everywhere. So that's it. Thank you. And please don't hesitate to reach out if you have any difficulties, any questions. And bye-bye.
Thanks for that wonderful session. I hope everybody is rushing off to go to Spatial Chat and chat some more with our speaker. Next up, our gold sponsor, Bitvavo, is a user-friendly trading platform with low fees and more than 175 cryptocurrencies, including Bitcoin, Ethereum, and Cardano. Our next session is by Naomi. Naomi is a software development engineer at Adobe on the globalization core services team, where she leads internationalization and localization for Creative Cloud products. With this talk, Naomi aims to provide a high-level overview of internationalization, globalization, and localization best practices, why these are important, and how to implement them in design, UX, and within any JavaScript code base as well, using vanilla JavaScript examples and top open source library recommendations. So get your pencil out and take some notes. Please go to the community track for your questions and your encouragement, your applause, emojis, and feel free to ask questions. Naomi, the stage is yours.
Hello, JS Nation. Thanks for joining me today. I'm really excited to share with you all some ideas about building JavaScript apps with internationalization in mind. So my name is Naomi Meyer, and I work on the globalization engineering team at Adobe, where I do internationalization engineering for a lot of different Adobe apps. So this is where you can find me online, my Twitter and my website. And if there's anything that you're feeling passionately about, please let me know. I would love to continue this conversation online. So here's our agenda for today. I'm going to start with a name example and then move into some definitions of localization, internationalization, and globalization, just to kind of level set and make sure that we're all on the same page. And then I'll move into my top 5 tips to avoid the most common mistakes that we find with internationalizing JavaScript, and then end on culturalization. So overall, the aim of this kind of general presentation is to encourage you all to create experiences that are equally usable, relevant, and meaningful for users all across the globe, and to really amplify the voices of our global users. So I would like to invite you all and encourage you, my fellow JS coders, to go out there and really put the world in the World Wide Web. So let's talk about how we can do that. Let's start with a name example. So this is a very common string that we see often in English, where folks introduce themselves with the syntax of "Hello, my name is Naomi Meyer." So this is my first name or given name in blue, followed by my last name, family name, or surname. So if we take this simple string and translate it here into Japanese, Hindi, Hebrew, Arabic, Korean, and Chinese, we can see that syntax of first name, last name is sometimes switched. Sometimes it's last name, first name. And obviously, sometimes the text is read left to right. Sometimes the text is read right to left. And so this is kind of just a really visual representation of how we can identify a user's name differently across different locales. And this is kind of a high level problem that we're trying to solve with internationalization. And, my name is kind of a simple American English name. Here's an example of some other names from Brazil and Portuguese, Russia, and in India of, kind of common names and how they don't necessarily fit easily into this simple first name, last name paradigm. And some of the challenges that we're facing here. So this is how Google handles that problem with when you create a Google account, you enter a first name and a last name as distinct data fields. So users from regions and languages that don't necessarily follow that paradigm are going to have troubles. But Twitter recently came out with a great solution to this problem where they have just a simple name field where a user can go in and enter their name in their native script in their native first name, last name, first name kind of syntax, and it will be stored as one distinct field. So I think this is a really cool solution to the username internationalization problem. So now that our heads are kind of thinking more deeply about internationalization, let's move on to some definitions. So what are we talking about here? When we start at the most granular level, we have translation, where hello becomes hola, konnichiwa, bonjour. And then the next sort of level of granularity would be localization, and that's in English, we spell localization with a Z in the United States, but if you go over to the United Kingdom, localization is spelled with an S. And so those are both English, but they're different regional dialectic variations. So that's sort of the level of locale that we get into with localization. The next sort of level up of granularity is internationalization. And this is more on the engineering side where we wrap the application in tools for internationalization so that they can be shipped in translated forms. So this is where we go into the pipes, where we, if a software is a house, we'll reach into the pipes, change them out, and create a system that can be easily translated. Then the next level of granularity is globalization. And these kind of all fall under this umbrella of globalization, or G11N. And important to note that these are numeric acronyms. So for globalization, we take the first character G, followed by the number of characters, and then the last character N. And the more I think about these sort of big ideas, culture is deeply rooted in our thinking patterns, and it affects how our users interact with and benefit from digital experiences. So internationalization or globalization really go way beyond translation. And by acknowledging cultural characteristics and really celebrating the differences, we're creating with innovation and sort of accessibility and building products for the whole world of users. So if we look at these two visualizations, we can see that the majority of people on Earth do not speak English as their first language, but we can see that the majority of digital content is in English right now. So this is really an opportunity for us to expand digital content online into different languages for users all across the world to use in their native mother tongues. So let's talk about the top 5 tips for how we can do that. So tip number 1 is to use Unicode everywhere. So to start, what is Unicode? I'm sure we're all very familiar with seeing this line in our HTML tags where we say meta char set equals UTF-8 for web. So what is UTF? UTF is the Unicode transformation format. Unicode, right? So here's how UTF is represented across 8, 16, and 32 bits for the character A and the character A in Japanese. And so UTF-8 is most common on the web. UTF-16 is used by Java and Windows, and 32 are used by Linux and various Unix systems. So UTF is really cool because it's reversible, and so conversions between all are algorithmically based and fast and prevent lossless round tripping. So we know that many programming languages will directly use one of these UTF encodings, but as JavaScript engineers, which UTF is JavaScript? This is really important when we think about encoding. And whether, you're in React or Angular or Vue or Svelte, they're all under the hood encoded in the same way. So if we look at the spec, ECMAScript, the standardized version of JavaScript, defines how characters should be interpreted as either UCS2 or UTF-16. So UCS2 is a 2-byte universal character set versus UTF-16, which is as a 16-bit Unicode transformation format. So these are two different contrasting systems. So it creates a lot of really weird and interesting JavaScript bugs when dealing with encoding of characters because of these contrasting systems. One is always 2 bytes, and the other uses surrogate pairs. So let's talk about some of those kind of common bugs that we see. So the first one is with combining marks. So combining marks where we take a Unicode code point for the Latin small letter A, and then we add a combining mark code point. Here we have a combining ring above it. That's how it's for a Danish atomic grapheme character that has A with a little circle over it. So the A with the little circle over it are 2 separate code points that combine to make one. So if we take these 2 separate characters and console log them, we can see what's returned is the A with a little circle above it. Great, but because these are 2 separate characters, we can see some problems. So similar to that A with the circle above it, we have the E with the accented E in cafe, that we see in Spanish. So if we define that variable as drink with CAFE with the final combining mark as the accent in cafe, and then we console log that variable drink, we can see cafe is returned. But then if we check drink.length, the length is 5. And if we try and split that string into an array, we can see that the final index of the array is that combining mark. So as I'm sure you can imagine, a lot of confusion will arise when trying to do string manipulation with combining marks when you forget that these code sequences exist. So how can we handle that is using the normalize method that's built into JavaScript. So string.prototype.normalize returns the Unicode normalization form of the string, which is really handy straight out of JavaScript. So if we take that same variable drink, that's cafe with the combining mark, and normalize that string, we can now see that the length is returned as 4, and the final index of the array, when split, is E with the accent above it. So we don't get that extra index with the combining mark. So this is really great to keep in mind to avoid localization bugs when doing string manipulation. But it's also really important from the human perspective. So I saw this tweet recently that says, found on a US government website, everyone, this is what systemic racism is. It's when folks are excluded. So this person, Raquel Velez, her last name is in Spanish and it has an accent over the E, but she can't enter her last name in the last name field of a US government form because of the combining mark in Unicode that is creating encoding issues here. So by fixing, simple string encoding issues, we can help solve these problems on the human level. So let's move on to tip number 2. to wrap all strings in an object for translation. So from a really high level kind of pseudocode example here, we can take a hard-coded hello string of hello world, and then, so this is a hard-coded string, this is what not to do. But what we can do instead is take this string and wrap it in an internationalization object where we have a list of resources for each of the different locales. So here we can see English has an object with the key of hello message that equals the key value. The value is hello world. And then we can display that variable of hello message as the key and return hello world as the value. So here's this simple example in English. And then what we can do is we can add additional locales in our resource files. So here's this locale of Japanese, with konnichiwa. And best practice is to take each of these different resources as distinct locales and store them as different files in your list of files. And there's lots of different ways to do that. There's a lot of really great open source tools that are available. Here's a list of some that I recommend. I18Next, Globalize.js, Polyglot.js, and Localize. There's a lot more that are excellent systems to basically wrap all of your strings in an object for translation. So I'm not going to go into the deep guts of these individual implementations, but instead I want to focus on more solutions that are tool agnostic and talk about sort of big high-level tips that you can use across all of these different tools. So the next tip number 3, is to test in different languages and different character sets. So a great solution to testing in different languages and different character sets is to use the pile of poo test. So this is from Mateus Baynerds, and he says if you include a pile of poo emoji because of the underlying Unicode encoding in JavaScript, these emojis will test for how you're handling complex Unicode characters. Or you can also include this long string of internationalization with piles of poo emojis to ensure encoding is working correctly end to end in your JavaScript app. And I highly recommend testing as many complex characters as possible. So tip number 4 is to wrap all of your numbers, especially dates, times, and currencies, in an object for internationalization. So a wonderful solution that comes out of the box with JavaScript is the JSINTL object. That is an API that has a lot of really cool stuff in here that's, with JavaScript for free. So just a few examples of what's available in the INTL object for dates and times. Here we have the number format, where we can input a locale and a long integer and then display it correctly based on that locale setting. So here we can see that long integer in English with a comma every third integer, German with a period, Russian with a space, and then in Tamil and Hindi, the comma is included in a different location within that long integer because they have different number ordering systems, which I think is pretty cool. And then also, the age-old question, what day is it today? Depends on where you're asking. Sometimes this can be January 2nd. Sometimes this can be February 1st. Here's a fun visualization of how dates change depending on where you're displaying them. Here's an example of using the JavaScript INTL object with the date time format, where we can format a range of dates. So if we input a start date and an end date, this is how that will look across locales. And I think it's really exciting to see all those locale-specific symbols. Also, Unicode has ISO to help you handle dates, and that's another wonderful open source project. So my tip number 5 is to build flexible layouts to accommodate translated text. So different languages obviously have different lengths of text. The Adobe Spectrum Design System recommends using these rules. So depending on the length of your English text, to allow, from 300% to 30% expansion of text, and to test in these different longer and shorter lengths of text is really important. And then also remember that things like italics and bold and line height sizing can really change in different languages, and to consider user readability in complex Japanese or Chinese or Korean type characters here. So those are my top 5 big tips to keep in mind. But there's also a lot of things that are really important in internationalization that I just don't have time to go over today. So some things just to keep in mind also are to avoid concatenating strings because the order of words will change in different languages. And then also to be sure to handle sorting, filtering, and searching in non-English characters. And then be sure to use consistent locale code handling. So our recommendation is to use BCP 47 to define your locales, and make sure that wherever the locale is defined is consistent across the full app. And then remember that keyboards and keyboard shortcuts can vary in different regions. And so, be sure to keep that in mind. And remember, if you have a keyboard shortcut key, to check the different regional layouts of keyboards. And then, of course, left to right is changes the layout of your full UI for users who are reading left to right. And so if you are supporting those users, make sure to keep that in mind. On each of my slides, I have links to further documentation, so please feel free to go in and read that and learn more about how to handle all of these complicated cases. I just unfortunately don't have time to talk about all the amazing things I'd love to talk about today, but let's move on to cultural considerations to keep in mind in the big picture of internationalization. So, it is completely, if a user is searching for an image to represent a holiday, all of these different images are valid, true, wonderful holidays across the world. And acknowledging different cultures is so important. Also, food. If a user is searching for delicious food, I think we would all agree that having a variety, spice and sweet and savory, having all these different choices is really great and important. And similar to having a variety of delicious food choices, having a variety of languages is culturally useful and important. So this map represents, each dot represents a language that is currently at risk. So by enabling different languages and having different language users really be able to navigate our apps in their native mother tongues, we are truly innovating and building for the full world of humans across Earth. So please join me, avoid your assumptions, broaden your mind, and go out there and put the world in the World Wide Web. Thank you so much.
Oh, that was already our last session, but remember, there's still time to join the spatial chat and chat some more with our speakers. But now for the after party, let's play some games together, shall we? We have a couple of them lined up for you. So Cozy Juicy Reel is an online board game with a very un-game-like purpose to kindle fun, authentic, and connecting interactions as opposed to brutal competition. Join to enjoy. Or alternatively, there's the Quake tournament as well. So you can go ahead and join that one as well. I remember that last time it was great fun. Once again, a big thank you to our sponsors. Without our sponsors, this conference couldn't have taken place. So thank you, thank you, thank you. And of course, thank you to the JSNation team for organizing this entire event for us as well. I had a blast, absolutely. So thank you, JSNation. Then also, please, your feedback really helps the team in improving the event experience even more. So find the feedback form at jsnation.com/feedback. Take your time with it and leave your feedbacks and thoughts there. Thank you. If you like this event, you might want to check out other events by JSNation as well, like the ones that are on the slide, and get yourself a multipass. Who knows? And very soon there will be a chance to meet each other at the next conferences as well, like React Advanced and Vue.js London in October, in both London, but also online. Thanks again, everyone, you, the attendees as well. I have had a blast, and I hope you had a great time as well.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
AGGrid's high-performance JavaScript data grid works with Angular, Vue, and React. It easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Crypto. A turbulent world full of risks and opportunities. Discover it through a trusted platform. Join the 1 million Dutch users of Bitfavo, the crypto exchange of the Netherlands. Crypto starts with Bitfavo.
What is intelligent industry with Capgemini? We could tell you it's how our team of experts help you use 5G, AI, and IoT to connect intelligent devices, factories, and software ecosystems to harness the power of data and foster innovation. But in human terms, it's business and tech.
So making our products intelligent really does make life
easier, better,
really working in sync. Capgemini. Get the future you want.
The content you create works harder across more channels, while you work smarter with powerful tools for workflows, editing, and even building your own apps. Say hello to a better way to build and deliver digital experiences. Contentful.